All right, hello and welcome to uh, our our second Twitter space for Ether Cosmology. Today we're going to be going over Shane's model. I'm going to join the panel here.
Hearing the echo of myself.
All right, well, there we go, right? Yeah. All right. I joined on 2 tabs. So
please bear with us just a moment here, everybody.
You sound kind of echoey, Shane.
Yeah,
or like,
where
like
the
you're,
echo from?
or like you're far away.
Where? Okay. Let's see what happened here. Let's do this. Wrong microphone.
Testing. All right.
Sound good, Toby?
Testing. Am I getting an audio echo from one of you guys? Is that what I was hearing?
So it sounded like Shane was far away from his headset, or like it was picking up audio from a different source, you know?
Okay. In any case, I'm ready to go live whenever you two are. Thanks, everyone, for tuning in here. To give us just another moment here, we're about to kick off our live streams.
Oh, dude, that's so funny. I actually super went live already, but you're good.
No, where did Shane go?
No worries. Yo, can you hear me? Toby. While we're waiting, we're gonna listen to some of Toby's music in the background.
Oh yeah, I think if I joined on my phone, that would have been better.
Well, I think Shane is here now.
Oh, is that?
Yeah, you're coming in clear, Shane. You're good. Right. Toby, can you hear me?
Yeah, I hear you.
Okay, perfect.
But I think one of you guys are echoing.
Yeah, where is that coming from? I wonder. How many Twitter tabs do I have open? Let's start with that.
Test. Shane, are you there testing?
Yeah, I'm good. Right? You hear me? Nope. Oops. We good, right? Everyone's good?
Yeah, I can hear you fine. You're good. Toby, you're good. There's no echo. We're all clear.
Try the phone.
Allegedly. So far.
How's my stream? All right, let's bring it in then.
Yeah, for some reason, I don't get any of Shane's audio. I only hear Alan.
And it echoes when you talk, Toby. I can hear feedback.
Yeah, what's up with that? Is it me too?
Yeah, it wasn't doing it before, but now it is.
What the hell is feedbacking? I'm just gonna start closing stuff. Oh, are you sharing my Discord screen, dude? Is that not sharing audio? Mute that bitch.
Yeah, it's muted.
Oh.
Or mine is, anyway. Yo, Toby, that propagation song is fire, dog.
There we go. All right. So we're live. Everyone's good.
Testing. Hello.
Yep.
All right. So we're live. I'll go ahead and start my stream.
Sorry, I think I was echoing there. My bad.
We found the problem. It was Alan.
Well, that time.
I still only hear Shane through my headphones.
Nope, I hear
Ether
Toby echo.
Cosmology. Is anyone
Yeah.
else not hearing Shane?
I can hear Shane, and I can hear you echoing now. I can hear me now through you.
Okay, change of plans.
Yes.
Testing. Hello.
Yep. That's better.
Okay, so we'll just do it like this. You guys just stream. I'm not going to stream anymore. I'm just going to host this from my phone here, and then we can just move along.
That was it. What the hell was that? What'd you switch from? You were off the phone, huh?
Yeah,
Oh,
I'm no
on the
longer
remote.
going to use my microphone on my PC.
That's what it was.
Well, I couldn't hear you in the audio from my PC, so streaming when I can't hear you is not going to do us any good.
Right.
It's just
Right.
Twitter being, yeah, I don't know. Any case, thank you everyone for bearing with us through all the weird technical glitches there. So we're going to have today a talk about Shane's flat Earth model. If you want to pull it up yourself, you can go to planar.earth, https://planar.earth, or you go to adl.place and just click on Shane's FE model, and then you can find the the model in question. Anything you want to say, Shane?
Nope. Thanks, Toby. So like all the explanations and prefaces, and I put out a video explaining it all, and all the explanations are there. So let's just do like a brief history of why we chose to do that, and then we can bring people up who have questions, and we can go through it, right? So if y'all don't know Mr. Walter Bislin, he created this model a long time ago where we came to flat Earth, and I immediately grabbed it and started using it to portray celestial phenomenon on flat Earth, right? Because when I first saw it, I was like, whoa, that's how all the celestial phenomenon work, obviously, right? So that model to me is like what gave me the understanding of flat Earth celestial observation, essentially. So I've always been using it. Of course, Globers have always been shouting things, oh, you can't believe you're using that globe model. And it's like, well, yeah, all observations aren't globe observations. That's silly, right? So there's always been that back and forth. But essentially, it's the only way that I know of to show celestial phenomenon on flat Earth. So when we put it up, we wanted to make sure everyone had the opportunity to do so, essentially. That's pretty much it. Who's got some questions? Who wants to talk?
Okay, yeah. So if you guys want to speak or ask questions, just use the handshake emote or whatever it is, what have you. Use something involving a hand, and somebody will get to you.
Yeah, it's meant to be about the community, this event. So let's make sure we bring you guys up here.
Yeah, absolutely. Absolutely. This is to answer all questions. And especially so if anyone's been hitting you up in the globe or hitting you up in the timeline, asking questions, pressing you, send them here right now. This is where we can get answers. Or what you can do is link that thread, link their question or whatever in the purple pill thing, and we'll read it and go over it and talk about it. So to start us off, while we're okay, here we go. We got Chris or Christ wants to start us off. So go ahead, Christ.
Am I on?
Yes, sir.
Yeah.
Hello? Oh, okay. Yeah. Alan, Toby, and Shane. Been following you guys for a couple of months now and just kind of been lurking, been a listener. I think you guys are doing an incredible public service. Blown away, just loving the spaces. Um, Totally new to the subject too, so you have to bear with me. I am a complete noob at this topic. And I'm on Netflix today and I'm watching Three Body Problem. And it just dawns on me like everything when it comes to science, especially like extraterrestrial science and science fiction, presupposes that we're on planet Earth, we're on a spinning globe, that the solar system. Do you know what I mean? Like this is a completely captured public narrative, and I would just love to hear about how you guys got onto this subject first, because you know there's a question in there somewhere. I'm sure.
I mean, we can definitely do like origin stories and a little bit after. But
Awesome.
Did you have
Well, yeah,
any...
that's a pretty loaded question. Shane, Alan, one of you guys want to go ahead?
I like what Shane was starting to say there.
Yeah, I was gonna be like, yeah, we can do like an origin story afterwards, or we can just try to hit model questions real quick. Although
I'll go ahead.
I'm sorry. Yeah,
super,
I'm just
super
I can go ahead.
appreciative to hear
No,
what
I'm
you have
happy
say.
to. So for me, I had a brother that was sending me a bunch of stuff about flat Earth and about just about flat Earth in general, really. And I already was super skeptical of NASA for a long time, and so I didn't really think about it too much past that. I didn't really believe in the moon landing. But then I basically started like getting annoyed with my brother, so I decided I was going to go, just look into it, find something to shut him up or something, And then as I started looking for that something, I started to, really start to see a lot of red flags everywhere I looked. And for me, it was especially when I realized that when they went to measure the motion of the Earth was when they decided was like what led to special relativity and like all the relativistic theories. Like when I realized that was a big click in my brain, because relativity never sat well with me. It's kind of intuitively nonsensical. And so that really clicked with me. And so the flat Earth thing, seeing too far, optics, that for me took a little bit more like effort to get over, because it's kind of like an ego thing for me. Like I like to not realize your whole life that like you're on a plane instead of a curved surface, and that like literally you just never looked at the math to realize that you see too far. Like that's kind of difficult. But like to be like, oh well, relativity was nonsense, like that was easier for me for some reason, like because it's just like I already knew that. Like I already knew relativity was nonsense. So
Yeah, I've
so
been
yeah,
looking
kind
at
of.
Einstein's theories of special and general relativity, and it's gibberish. Like do you think he was like deployed to like cover up? Do you know what I'm saying? Like to
Yeah, that
put a
we
band-aid
could go
on.
on about that all night actually. And actually, if you want, we can drop you a link to a document. There's a lot of source material on that out there if you want. And there's
Like he's
yeah,
goofy.
it's quite skeptical.
Goofy.
Yeah, it's quite questionable. But just so we
I
don't
don't
get
mean to
too far
derail,
off in the
guys. I'm
weeds
sorry.
here. Oh no, you're great. You're great. But yeah, so anyone else have like a question? Ken, I see you've got your hand up. You want to talk about got a question or thought or comment?
Yeah, let me turn this TV off. Somebody left it on. I don't need it in the background. Yeah, Shane talked about what his model does do, because a lot of people were saying, "Oh, it doesn't do this, it doesn't do that." and I remember him listing a bunch of things that it does, but I couldn't quite catch them all. I think what I did catch was it's basically for celestial observations. You can track the sun, the moon, and the stars with it. Is there more to it than that?
Well, it does like light distribution pretty well. So anything that's like observation based, and specifically, yeah, like stars, sun, and moon. So
Shane, you there?
eclipses, yeah. Can you guys not hear me?
I can hear you.
Oh, could Ken not hear me?
I
No,
think
I can hear you.
Oh, all right.
No,
I thought I
proceed
heard
then.
someone
I
say couldn't hear
apologize.
me.
I do not, but proceed.
Crap. Toby, you gotta like rejoin. It happens sometime in space. It happens all the time on Flat Earth Friday. I mean, sometimes you just can't hear one person. Super frustrating. But yeah, dude. So like all celestial phenomena, like it's not what it doesn't do is like the map stuff. It doesn't do ground based things. It doesn't do country sizes. It's not the geographical flight path display agent, right? It's just for stars, sun and moon, celestial phenomenon, the Southern Cross observation, things that like before now would have been inexplicable to most flat Earth things. That's essentially what it's for. Am I still speaking?
no, you're good. Yeah.
All right.
So to be clear, it's not for. So if someone were to like apply flight paths to it, or say Australia distance doesn't look right on it, it's not really the purpose of it. It's just star observations relative to the lat long system.
Yep, I would say that's the main goal of it is definitely the stars, like to display the stars to show how circumpolar stars work, how southern optic convergence point as southern pole works. That's essentially the big one.
Gotcha. So you could say that the purpose of the map in there is just for visual clarity, right? Like you could put any map in there. Really, the purpose of it is just the lat long coordinate system and the sky, right?
Yeah,
awesome. So earlier when you were saying the light distribution, right? Can you talk about that a little bit, like how they explain it on a globe versus what we see on the plane?
Right. So light distribution is one of those things that it shows really well, just because, like on the globe, they pretend that the terminator line is perfect all the way, right? There's that big discrepancy over, well, when the sun rises, it should rise for everyone on the same side of the plane all at once. But what you get is an equidistant sort of distribution of light like this, right? Like I'm showing. Oh, let's see. Am I showing something?
Yep.
By the way, everyone who wants to look at visuals should be watching the stream. I'm streaming to Twitter, I think. And on that stream should be my display over here for what we're looking at. It might be a couple second delay. But yeah, so this shows the light distribution perfectly. Like if you start at like equinox when it is perfectly halfway distributed, then this model shows it perfectly, right? So you can see exactly where the terminator line is equidistant down the middle. And that's, of course, an effect of the sun height. And what the difficult thing for most people to understand right here is that like this thing right here from the different solstice. So in the summer solstice to us, when the light wraps around like that is definitely an effect. That is how the light looks on any map you look at it, right? So to try and put that on the model is kind of weird. To try and put that on the sun is kind of weird. That's like that distribution is called coffee cup caustic, and it's probably an effect of multiple things, including some sort of reflective thing in the background, right? So that's how the light works on flat Earth, on regular Earth, on globe Earth, on any map you want to look at. It always does this, right? Matching out throughout the year, half, and then less than half, then more than half, all the way through.
Oh, well, thank you. So as the sun is completing its analemma, the light distribution changes relative to that, and that's how we see it every day?
Absolutely, yeah. And they'll also show this on that model. The analemma gets shown nicely because it goes in neat little figure 8 patterns from wherever you are, as the other part. From wherever you are on Earth, you see it in that way. So each person would see this at a different spot, right? The analemma would appear.
We get our own personalized analemma, guys.
There you go. Exactly.
Very cool. That's how you know the sun's 93 million miles away, right? So let's talk about that a little bit. Let's do before we get into distances for everything, right? Because obviously, is this based on heliocentric distances and all that? We'll get to that in 1 second. I want to bring up Kevin real quick. He's got a quick question for us. Let me check the hands. If possible, can you bring up All right. I actually don't even see any requests, so it's purpose or it's not. I have no purpose as a mod. That's cool. His name his
Oh,
username is mobile something. If you see
Hmm.
mobile something, can you bring him up? Oh, I see it. I see it now. I
I
see it
can do
now.
that. Approve. Look, I got it.
Nice.
Mobiler.
You hear me?
Yep.
Yes, sir.
He's got delayed stream playing somewhere.
You hear me now? I don't hear you. I hear you on my notebook, but not on my phone. That's strange.
Oh yeah, Twitter's ass, dude. I mean, Elon Musk is cool or whatever. Mars is great. We can bring you down and bring you back up and see if that helps.
Yeah, but I can ask my question anyways. I
Oh, yeah,
can't
true.
hear you, or just
Yeah,
I
go
will
ahead.
echo, but I will ask it anyway. I asked you on the chat, but Mike, I'm not sure what the distance is, because it's about the apparent distance to Polaris. If we see to equal distance in every direction, how does visual curving at extreme distances play into that? We say that hyperbolic vision makes a difference. We see curved visual, but I don't see how there are anyways different distances, because it should be only one distance every direction, isn't it?
Yep. Equidistant in every direction, sure. But you're asking like, so what's the difference between apparent and actual distances, right? It only goes to below 69 or whatever on the chart because you're using an apparent distance. So when it's apparently over the horizon, you can't see it. So that distance judgment based on the formula gets skewed, right? You're asking how curved visual space affects it. I mean, that's just in the degree in which it's affected in the far and near field. And essentially they let you use where it's least affected, right? So that's how they're connected. They just the part where it would be skewed, where it would be nonlinear and appears say logarithmic, then that's when they do corrections to allow you to use the actual angle. So it's between like what 150 and 180 on the other side, and 0 and 30 essentially is where they have used corrections.
What and while you were explaining that too, you had a thing up too where you were showing that relationship.
Oh, I couldn't see
that
it on
what-
my stream. Yeah, that's why I was like,
Yeah.
oh, I'm not showing that.
No, it was solid on Discord, so it's
Yeah.
on. It's in the background. We're good.
Okay, yeah, that was the chart we made when we graphed out the 69 miles per degree, which would be an actual relationship we can use on flat Earth, because we did prove mathematically that as you process laterally x along the surface, that the personal celestial sphere will move 1 degree upward or to you, depending on the direction of travel, right? Everyone likes to go through that. But when you go through the angles there, you have to keep it at a forced limit of distance. So that's where the 3959 comes in with the good old unit circle, just forcing that visible radius along that as we use basic trig to progress from 0 to 90 degrees, right? So that's how we showed that that's definitely possible on a flat Earth and not specific to heliocentrism, and certainly not due to curvature. Anyway, that was just the chart, the graph that would show. Actually, here's the portion where it would be linear, all the above 20 and below like 70 or whatever, where they would let you use it, and then beyond that's where they have you correct. Yep.
All right, Kevin, was that did you get all that? I know there was like a slight delay or whatever, so I'll give you a minute to. Actually, I think he already dropped down. Maybe. Nope, he's still here. I'll give you a minute to respond.
Did you hear me?
No, he did. It's the audio's coming through his other device, so there's just
Right.
a slight catch up mechanic. But Yeah, here he is.
So what's the apparent height, Shane? The apparent height is for every star, or is it for Polaris only, or in this scale, in this table?
Apparent height is all you ever deal with. It's all we ever see. It's all any person ever sees or deals with. So it seems silly to work with anything else. And that's and the actual height is where you find the 6210 and all the other variables, not in the actual perceived height, right? It's so long of a delay.
Yeah, I'm. Why is the apparent height given in miles? Couldn't you? Isn't the miles, the apparent miles in the dome, always the same? Couldn't you only give angles?
Well, you give apparent angles, which translate to apparent heights. We have, you guys know who F6, F5 Hellcat is? So what's the request to speak?
Yep.
Cool.
1 second. I might be able to get him.
I'm actually able to mod from my computer today. This is working out really well.
You know what? That's awesome.
That's the good thing. Sometimes Twitter Spaces don't fucking suck. You know?
Welcome. Did anyone have a question about the model or anything? Or do we have to ask our own questions?
I think we're just shooting the shit at this point.
No, you're good. Okay, so so I think was there one more from Kevin? I think you had a follow-up too about how Shane derived the radius for optics and all that. I know that's not specifically model related, but it is kind of related because it, celestial sphere and whatnot. Would you mind giving a quick explanation of that?
Yeah. We actually just went to, who was the Clubhouse on Meatballs? I think Meatballs here. Meatball should come up. We went to Meatball Space to do a nice dissertation on that to answer a challenger from a PhD or whatever. And that was pretty fun. I recorded that. We should put that up in a little bit. But essentially, was it to do with the radius criterion and the wavelength and diameter specifically chosen, or was it something else?
Yeah. Now I hear you at the right time. It was Ruhif at Jeranism. He said, when you have a telescope, it would skew the whole thing, but it's meaningless anyways because the 1.22 anyways remains with the eye.
Yeah, so that radius criterion with 1.22, that's a scalar, right? It's first of all, it's a ratio, and it depends on the starting criteria. So you can choose a different wavelength, you can choose a different aperture, sure, but then it would scale covariantly with the rest of the variables. It was pretty funny because you can actually derive it backwards. You can derive the angular resolution limit in degrees or radians backwards using the radius and the apparent drop rate. So like to say that you can choose different variables to negate the whole thing is silly. Perhaps they're unaware that it goes, back and forth, to and fro, left and right, etc. So let me find the wonderful formula that'll help you derive it any which way you want to. Right? I think it's
This is the biggest criticism that I've seen come out of or put forward for what Shane is putting forward, is that if you change the optics, it somehow changes everything, right? But it's you can derive it from the other variables though.
Yeah, and when you change from a human eye to a telescope, sure, you're increasing resolvability by changing the wavelength and the diameter. Like literally, the diameter is how telescopes work. When they change it so drastically, is how they see larger objects. And essentially, what radius criterion really is meant to describe is this intercedence point of these two objects between where you're viewing and when you're seeing. Like so, your eyeball and the object has to pass through this aperture, and then they go through this divergent connection where that divergence will go further or nearer depending on the diameter. So that's all that is, right? That's a specific frame of optics, and changing that won't change anything because if you move from a human eye to a telescope to a camera, that portion gets covariantly scaled. So it doesn't change the giant end result of it. It just proportions it because they're using the distance to the horizon as the next part. If you change the aperture, can you see further? Sure. Does that increase your distance to the horizon? Absolutely. So everything scales covariantly. Hold on, let's get the formula that's there because I think it's really funny that you can literally have an absolute variableless, constantless formula that shows all this relationships perfectly. And I think it came from, I don't think Toby said he made it. It came from one of us, I forget. It is, oh man, it's beautiful, right? So R, meaning radius, equals D, which would be the distance to the horizon over tangent of theta, or the angular resolution limit. Let's go ahead and put that in the chat up here. Oh, I can add it to the comment for spaces. Perfect. So we'll throw it in there for everyone to see. Have fun.
Ooh, I'm gonna need you to meticulously tag that, brother. I'm just kidding. I'll do it after we're done.
Yeah, I forgot to tag everything. You're right.
But yeah, definitely. Well, you can edit actually, so it's not a big deal for you.
Yeah. Yep. Oh, that's right. Because the actual oh, I can't edit that. Whatever.
Nice.
When you get the radius down to like the actual degree of specificity, it's when you choose the human eye in 1.2 and the red orange wavelength for light, which is literally like the most persistently resistant to refraction at surface level, which is why we chose it to be the mean average of all the criteria and circumstances to get the best possible result. But if they don't like that, you can backwards derive it from your chosen optical drop rate at whatever aperture diameter you're working with, and including the radius to get the actual resolution limit where it would not become resolvable. Anyone on the model?
I'm gonna check the timeline here and see if we got any questions or something like that. So we got a muted lad. He says, "Coffee cup caustic effect. What the F did Shane's explanation make any sense?" Yeah. So would you want to touch back on the coffee cup caustic and how it's I think it's like a representation of the limit of our curved visual space, right? Now, what they say for the globularist explanation, they say that there's ice crystals in the atmosphere and it's causing this weird, light pattern situation, right?
Oh, that's for sundogs, I think.
Oh, is that not the same kind of? Is that not a coffee cup caustic?
It's like a reflective issue for sure, but they say ice crystals follow the sun when it has those three suns, when it looks like it's being reflected or whatever. It has no, those ice crystals stay perfectly static in the air and then follow the moving sun all along its path, and that's why it looks like that. And you're like, yeah, that's retarded. Okay.
Oh, my bad. I thought those were the same thing, like just different words or whatever.
No, coffee cup caustic is like that stretching effect of light bending around a corner, not really a corner, around an angular or whatever, because of it has a reflective part essentially. Right? They did it because it's called coffee cup caustic because someone saw it through a coffee cup or something. I forget. I think Widget said that. I have a good visual image of it somewhere. Let's see. Is this it? Where the hell did you open? Oh boy. You got one, Alan? Does anyone get Toby? Do you got one somewhere? This one.
Oh, dude, my mic was muted the whole time and I was talking to no one. Fantastic. All right, so we got some mics here. So P Dubs, you pulled up. Do you have a question, sir? We can go ahead and get to that while Shane is looking for coffee images.
Yeah, do you guys think that it's possible to measure distances on Earth somewhat accurately?
That's an excellent question, bro. I think that it is, but I don't know if anyone ever has. All we've ever done is map globe distances, dude, on long, very short distances.
Map what? I didn't understand
you. We've only done globular distances, right? So there's a coordinate system that yields different distances that is the same in every map that's on Google Earth. It's on every metric and way that we use to compare distances. So whenever we say, hey, how far is this? We're citing and calling the same coordinate system. So
I didn't ask about coordinate system. I was just asking if we can measure distances on Earth.
Yeah, it sounds like maybe you didn't get it though, because all the distances would be from the coordinate system, right? Unless you want to measure
not at all. Not at all. No. That's not what I'm saying at all, Shane. before we even had a coordinate system, we were able to measure distances.
Well,
And we've been able to measure distances since the Roman times, right? I mean, there's a
that's
Roman
crazy.
mile.
And we've known the Earth is a globe since then too. I heard, don't we?
No, I didn't say anything about the globe yet.
Oh,
I'm just asking if we can measure distances, and you gave like a whole word salad about globular
All right.
distance. So can we measure distance on Earth or not?
Where
Are you
which
are
planet
you
are you on though?
are you looking for reference points between two places or what?
Yeah, eventually, yeah, we could do
Oh
that.
man,
Like
no way.
the distance from the North Pole to the equator. Like, can we agree on a few things? Or first, like the North
No.
Pole is at the center of the circle that is the equator, the 0 latitude line.
Whoops, that's loud for everyone, huh?
Is that something we could agree on?
Did you have questions on the model, bro? Like anyone?
Oh,
He's
you mean
asking-
Walter's model?
The model, yeah, the model. Right here, this model.
Walter's model.
Well, no, my model. It says Shane's model. Right
I
now.
have a
Oh, the
question.
model you
Confused.
just changed a couple numbers on.
Did I?
Yeah, it sounds like.
Did you prove it?
I
You know
don't
what
need
you're
to
talking about?
prove it to who?
To who the hell are you talking to, man? Who the hell are you?
I'm not trying to prove that you stole the model from Walter at all.
Who stole anything, dude?
I didn't say you stole anything. I asked.
Did you want to talk about map distances some more, or did you want to just?
I mean, I just asked if we could measure distance on Earth, and apparently this is a big conundrum for you guys. If I asked a normal
it's
person
hard.
around if they could measure
Super
distances
hard,
on Earth,
dude.
they'd probably say yes.
Absolutely. Yeah.
Yeah.
Yeah. Well, we can all look at Google Earth, right? And we can do geodesic
can look at-
arcs. We can use
what
the
do you think the
haversine to
basis-
get the
what do you
difference
think the
between
basis-
2
what do
points
you
on the
think the
surface of a
basis-
sphere. We can
What do
compare
you think the basis
geodesic lines for Google Earth. We could do a whole bunch of long lat convergence. Hey, we could even go in the tropic and do a complicated conversion to get the actual GPS coordinates from the length if we know that backwards to and forth, right?
So the length of the meter and the length of a nautical mile both have their origins in the distance from the equator to the North Pole. Agreed?
So you said measure distances, and then you want to reference a coordinate system. And then you say, well,
Well,
I'm not
no,
talking
yeah.
about a coordinate system. It's like you're very confused here. And if you don't,
Yes, let's get
like,
someone
we're,
else up
like
here,
yeah,
dude.
we're going to wrap it up, B. All right. There was somebody else who chimed in and had a question.
I had a question. For some reason, my audio cuts out when you come up on stage. I have an Android. Can you guys hear me okay?
Yep.
Yeah.
Yeah,
Yeah.
It happens
Yeah.
to
I
everyone,
can hear you.
Yeah. It cuts out sometimes. It's called the Elon special.
Okay. Anyways, I just had a question. The Bislin model was open sourced, is my understanding, which means, it's open sourced. What changes did you make to the model source code? And I think you published that, right? You got a link to the actual source code you modified.
Hold on, my dog's going nuts.
Yeah, while he's getting his dog, I'll give a brief answer on that. Yeah, it was what's it called? Common license or whatever it is, or I forget the terminology, but yeah, it's open source, and Shane has published it, and he'll get a link for you when he comes back.
Awesome, thanks.
Shane, I have a question though. If the Earth is flat, I mean, is there an edge to the Earth? Like, if we reach to the edge of the Earth, what would happen? If the Earth is flat
Yeah, 1 second.
in
Hold
your
dog.
model?
One second.
Shane, can you answer my question?
He's AFK, sir. Can you hear me?
Like any flat like flat Earth believers? Because I cannot even define if it's
Yo,
flat
He's
or round.
away from
Hey,
the keyboard, brother.
can you guys hear me? Could you let him know that Shane's AFK? He'll be back in a second.
All right, should be good unless he comes. We're good.
All right.
Okay, yeah, Shane. Shane, yeah. Can you answer my question though? I mean, since you have the flat Earth model, right?
I think Shane is away at the moment. I think we're having some technical issues here, and I believe Shane is not available at the moment. But if to answer your question, I know
He just got
like
back,
for
Toby.
me. Oh, okay.
Toby can't hear me. That's
Yeah,
right.
yeah, you're good. You're good.
All right, Shane. So you're no longer AFK, right? So you can hear me, right?
Yeah, it sounds like I don't want to have to answer any of your questions, though. We should give it to like people who are serious and have real questions.
Oh,
Does anyone
I'm
else?
pretty serious, like because if the Earth is flat, right, that means
It
it
sounds
has
like
an
you're
edge.
a globber, and it's not really for
Well,
you.
okay, sure. So
Yeah.
basically, right, 'cause any flat surface has an edge, right?
Great, good question. You got to step down, please.
Okay, so you can answer my question. So that means your
I
model
don't really
is
give
crap.
your questions, man. Right? We're here to answer questions for people who have them.
Okay,
And
so
he
how do you
has a
define a question?
question, so answer his
And how do
question.
you? Yeah, and how do you find a question that's genuine or not?
If it's flat, do we fall off the edge? Is not really the kind of question we're here to answer, bro. So
Why not, sir?
because that's retarded.
Hey,
Why is it
it's not.
retarded,
Hey,
sir?
listen. It's not the purpose of this space. Let's not detract too much. If you don't have a specific question regarding Shane's model that isn't what happens when we get to the edge of the model, we'd be happy to accommodate. If you have no further questions, then we're gonna have to
Oh,
rotate your
okay. So you
mic.
mean to say that the model has an edge too, right? Yeah. So what happens if we reach at the edge? Well, what happens if we reach the
Yo, I
edge?
can't see who's talking, so I'm just gonna shoot
Yeah.
first and ask questions later.
Okay. Are you trying to psyop me again? Like, is it like a mind game? I am the son of man and woman, bro.
Yeah.
Trying to figure out what it is you
Really answer a question
think
about a
you know
place we
that-
can't go to. I mean, that's first of
Right,
all, that would
right.
be
He's
my
asking
first thing I would
questions.
say. Never been there. As far as I know, we can't actually go there freely. So there you go. Appears to be a big
Boy.
ice shelf.
Dude, I thought we would have had more questions by now, honestly.
Let's see. There was what did I see the other day? Okay, who was the guy that had the grid turned off and his compass out, and he was saying that it was all stupid. Let's cover that real quick because that was a big deal.
Somebody, yeah, right. Somebody said it didn't quite match the sun in Australia, but what they did was, and by the way, the whole purpose of this model is that this personal azimuthal grid shows the apparent position locally for each observer. So what they did was they went ahead and turned that off, and then they said it doesn't work, right? So they did this sort of thing with no personal. So this sun is being observed by no one. And they went, look, it's wrong. It doesn't work. You see, the sun's over there. And you're like, oh, that's the single most retarded thing and most retarded use I've ever seen of this. But yeah, boy, if you put on the actual personal grid, which is the whole purpose of the model to show you where you see celestial phenomenon locally and optically for you, then it will show you the apparent rise of the sun. Essentially, this model is so good at sunrise that up here in the top, it shows the elevation and azimuth of the sunrise for every observer all over Earth for 3 years. So the one thing it's excellent at, he's like, it doesn't work. I'm like, okay. All right, buddy. That's okay, though. Sit down.
Oh, okay. I got to follow up. So one of the questions asked earlier was what changes did you make to the model? And do you have a link for the for the open source of it or anything like that?
Yeah, maybe we published it. It's also a tab on my database, and all the descriptions are on the database and on the website as well. And you can also just do what Globers did immediately and like, what is it, F12 view source or whatever, which will show you the JavaScript there too.
What were the changes that you made, if you don't mind? I don't know if you guys can still hear me or not.
Yep.
Well, tried to turn off the bendy lines. We had to change the radius of the personal grid, the actual translation method of GPS from bigger to smaller, this bigger sphere to smaller sphere. I left all the distances to the sun and the moon because they're just translated through a conversion factor to an optical size, which is all based on diameter of the sun. Of course, that's because the sun and the moon appear at 0.53 degrees, which can mean through a series of covariant scaling any number of distances and masses. So that's not a reliable way to determine anything, nor does it mean or necessitate any sort of direct distance. So that's crazy, but that's still in there because it gives some credibility to the optical diameter of the sun as it appears in your personal grid.
So every person in the model has a different view of the sun. Is that correct? Is that what I mean by personal? What is it? Personal celestial view or sphere?
Yeah, there's all sorts of names for it. Like I think Jaron called it a while back the personal atmospheric dome or whatever, but it's all concepts of the same thing. It's all different names for the same thing. Azimuthal grid of observability, azimuthal grid of vision, personal celestial sphere, take your pick. They're all kind of the same concept, different brandings.
Now, do you want to real quick touch on the mechanics of that, on how it's derived? Because it's like, isn't that just word salad? Isn't that something you just made up so you can role play as a flat earther, Shane? Or is this an actual optical phenomenon that was used to derive the sky founded by the Royal Society?
Right. So that relationship, which is why we started with the 69 miles per degree, because we got asked that question right away. That is where the whole disagreement started, right? So they essentially said, well, we know that the stars in Polaris declines 1 degree if we go a certain amount south. And I'm like, okay, well, we're going to say that is because of curvature, even though tall buildings, mountains, tall people, things, everything in the known universe also recedes into the horizon with distance proportionally. But we're going to say that's all for perspective and that the stars do it because of curvature. And you're like, okay, that's great. So the main disagreement and the disagreement over perspective with regard to the stars between globular and planar is literally, that relationship can't be that the stars can't recede into the horizon for any reason other than curvature. And essentially, that's absolutely wrong, right? But mathematically, we've already proven, as I said, as you progress laterally, at 69.07 statute miles across the surface, then the personal celestial sphere will move towards or from you, depending on your direction of travel. That is just how it works. So essentially, they backwards engineered that and told you that actually, instead of that happening the same way as it does for all the other things, that's because of curvature, and literally, behold, the world around you is curved. That was the basis of the globular, deception, I think.
All right. So to kind of break that down, the stars in the sky are apparent. The distances to them don't really matter. To establish a coordinate system but in which two people can use to circumnavigate on at great distances, you can use like an apparent distance based off of that 69 mile per degree relationship, right? And that's exactly what they did, right?
Yep, exactly.
Okay,
I got a
so
question.
go ahead.
Yeah, when we start, I don't know where I read it, but uh, I I was under the impression that like with the stars or whatever, someone suggested that we have like I don't know, it was like a 6,000 mile diameter view, something of that nature. And I'm wondering, if that isn't the cause of it to fall, because like presumably if I'm standing at the North Pole with Polaris directly over my head, it's not in my view unless I look straight up. But as I recede, more of the sky that's above me comes out into my view. And as I back away, it will, more of that sky keeps coming in, and that's Polaris will drop even farther because it becomes part of my overall view. And is that kind of what because there's like two domes, the celestial dome and then the personal one that's there. Is that kind of what that is? We only have a limited view of that entire dome.
Yeah, that's a pretty good description of it, man. Like if you're underneath Polaris, as you progress towards the equator, yeah, it would appear to recede. We can actually do a quick little demonstration of that if you'd like, which we can look from. We can bring the observer under Polaris, and then we can laterally process him out towards the equator. And as you get half towards the equator, Polaris would appear to dip to about 45 degrees on the observer's horizon, so it's no longer directly at your zenith. It's about halfway, and then when you get to the equator, it would be almost at 90 degrees, and you start to see the other antipode, which would be, the southern rotation, which would be an optical convergence point in the apparent south, only visible in the south while facing south. And then you can go even more south there, and you can see just the southern rotation, because Polaris will no longer be visible because you've transgressed past its elevation angle, right? So if it's just that angle, that elevation above the Earth, if you go further than that away from it, you shouldn't be able to see it anymore. That makes perfect sense.
Hey, do you guys hear me? You guys hear me?
Yep.
Yep.
Hey, what's up, guys?
Hey, maybe were you talking earlier, or were you just muted?
I might have been. I'm so sorry. It's like the first time I'm trying this out.
Damn. Yeah. If you want to talk, remember to hit the unmute button.
So my bad. I just posted a model that I made in Blender on the page. So the guy that was asking about what's beyond the ice wall, he can check that out. But it doesn't show like stuff beyond the wall because we don't know. But it shows that it's possible in a model of a flat Earth with the sun moving above it and the moon moving above it. I'm not sure if you guys saw it.
No. And Blender's cool though.
Yeah, I love it, man.
I wish I could use it.
Is it hard to use, or is it?
Yes.
No, it's not.
Okay,
You
well
need a
then,
PhD. You need a PhD for Blender.
No,
okay,
it's
well
not.
then, fuck me.
No, it's open source and there's a lot of great
Yes.
tutorials. It's a bit intimidating, but if anybody puts in some time, it's just like with anything. You just got to put in some time. I'm learning it
Yeah,
myself at the moment.
I started last year June, and I'm pretty good so far. It's not that bad if you check it out.
Yeah, that's awesome. I just played it. It's great.
Yeah.
Yeah, it's really cool.
Nice.
I made some other models. The first one I did was, anyways, I don't want to cut you guys' time off. I just wanted to say something about the stars. I live in the Caribbean, so I live in Aruba. That's like 12 degrees above the center line of the sun's path, quote unquote equator for the globe Earth, right? I'm in between the two tropics. I'm in between the Tropic of Cancer and the Tropic of Capricorn. If you guys are from the US, you're not going to be seeing the difference. You're not going to see the sun move to the north and then see the sun move to the south, but I can see this. During a whole year, you can see the sun moving to the south and then back to the north, right? If you think of, and I have this model out, and I wish to bring this out one day. I'm actually doing some housework right now, but if I was sitting by my computer, I would have shown you guys some crazy stuff. If you think of the whole heliocentric model and how the sun is in the center, and how throughout the year where the sun is moving to the south and then back to the north. What is weird is that you don't see the stars moving with the sun's motion. It's kind of weird. You see the sun moving all the way to the south, and then it starts coming back in January to the north, right? It moves all the way to the south in December the 22nd, and then it starts coming back until June the 22nd, right? It's all the way north. But when I see the sun moving south, all the way south, after that movement, I start seeing the Three Kings move to the north. Then I start seeing the Three Kings move to the south after when the sun is coming back to the north. And that doesn't work on a heliocentric model at all because it makes absolutely zero sense. I guess it's difficult to explain with words. I have to show it with like a Blender or something like that. But I don't know if you guys. Can anybody like?
Nah, you gotta model it out, bro. I can't visualize it. I'm so bad at that.
You should hang out with us since you're a Blender guy. We don't have a Blender guy. We need one of those, I think.
We need a Blender lab.
Oh, that's awesome.
For real.
That's awesome. That's awesome. Yeah, sure, man. I'm working right now. If I had free time, I could be chilling with you guys and showing you everything. I even model out how a shooting star would work on a globe Earth and on a flat Earth model, and it doesn't work on a globe Earth model.
Nice.
Because every single meteorites or shooting star should be coming from the horizon and shooting upwards.
Yep.
But we never see that ever.
Yeah, that's a good point. I think it says that one a lot.
Yeah. I have a really good model that shows that. And if I remake a model right now, I probably would make it way better because I've gained a lot of knowledge with Blender. So, yeah.
Yep.
But go ahead.
The sun's path is a good thing, though. A good thing to talk about because it's one thing that the model does really well, and we have to like angle it right. Like what I'm doing it right now, I'm looking at a side angle, and you can see the sun not only doing its analemma from summer to winter, but it also goes on a tilt. It goes inward and higher and outward and lower. And also, of course, you have the outward tangential velocity appearing to be faster than the inward, but really it's just like a clock hand going the same speed, right? So that's a wonderful thing to show in the model. And you can see the sun dipping in and around, up and back. And there's a good video, I think, that Habitat put it together called Ecliptic Overload, which literally has the sun all over and over and over, showing the analemma, showing the path, showing how it looks to each observer, which is really cool.
Yo, yeah, that reminded me, by the way. I didn't really get to talk earlier because we were having some audio issues, but I heard the back and forth going about the apparent sun, and I just wanted to chime in on that. What the refractive index, the idea of light curving downwards is somewhat true depending on where you are on the Earth, and more importantly on which quote unquote layer of the atmosphere that you're in, because as you go up and you get out of our lower atmosphere into the higher layers of the stratosphere and the ionosphere and such, the troposphere, the refractive indices actually flip flop back and forth. So sometimes the light's curving upwards, sometimes the light's curving downwards. And when you consider the fact that light is bending downwards when the sunlight gets to your eyes, it is a matter of fact measurably that it has refracted downwards. And so you're not going to see it no matter where you are on the Earth. You're never going to see it in its real position. And to take it even further, with starlight, it's the same thing. You look at Airy's failure. They did an experiment, a very simple experiment to tell whether the starlight had already moved. But when it comes to our eyes, to our optical viewpoint here on the Earth, they filled a telescope with water, and then they compared using that the light is going to bend in a certain way. It's going to bend upwards because of the speed is going to change with the refractive index of the water. And so thus, you should, if the Earth is moving and that's what's causing the starlight to come in at a different angle, then you would have to bend the telescope, because it's like you have to account for your literal movement. But Airy didn't have to bend his telescope, which means that the starlight had already been, the movement of the stars, the movement of the sky has already occurred when we see that light. So we're not seeing the stars in their real positions either. We're only seeing them in apparent positions. And that's because these things are coming through layers of atmosphere. And when you think about it, maybe the most simple way to think about it, one of the analogies I've used recently is, have a bunch of people stand around a pool, an empty swimming pool, and you throw a quarter in the empty swimming pool, and then you have everyone triangulate that spot of that quarter in that swimming pool. And depending on where they are, they're all going to get their angles. They're all going to look at it, and they're going to say, okay, yeah, we know the quarter is there. But then when you fill that pool with water, or better yet, let's say you fill it with some really thick salty water or something, and then you have everyone do that exact triangulation again, you're not gonna get a clear position on that quarter, because you're going to have refraction of the water that makes the quarter in an apparent position for everybody looking at it. So to try and expect us to be able to triangulate exact positions of things in the stars without knowing what that measured medium is, without even taking into account what we do know about the measured mediums, about the layers of the way that the refractive index is going to change in each layer of the atmosphere. Taking all that stuff into account, we know for a fact that these things are in apparent positions. So to try and tell us that, the ground beneath our feet must be curved because we can't tell exact positions of things in the sky, is really quite asinine and quite misleading. I would say you shouldn't really. That's one of the many reasons that we shouldn't be using the sky to make assertions about the ground beneath our feet.
Damn, that was great, Toby.
Yo, thanks.
Well said, man. And off of the back of that, I'd like to continue and further say that the distances to the stars. So earlier when we were talking about like the apparent position and whatnot, how they made it for navigation, right? They assumed everything's close and local, right? None of these crazy heliocentric distances, right? And the reason for that is because the angles have to match up for a two-party system, right? Now, when you get into the role play of heliocentrism, you can use those same stars and start getting distances based off of the assumed motion of Earth as the baseline for the triangle. And then you can actually then they can present their triangulation of star positions that are light years and light years away, unfathomable distances that don't actually matter, but it's nice and fun for everybody to calculate it out and it looks pretty, right? But the fact of the matter is the meaningfulness of the stars comes from a close and local, analyzing them for what they are, an apparent position that you could use to for navigation with a two-party system.
Yeah, apparent is all that matters, right? Apparent
Jesus,
is
dude, you have
all
a
that's ever
loud-ass-
used.
Jesus,
Sorry, yeah,
dude, you have a loud-ass keyboard.
It's also right next to the mic, so it's pretty bad. But so like apparent is all they ever use. There's a nice post from NASA that Gleam turned us onto where they were showing the phenomenon of the supermoon or something, and they were using a dome around the observer to show how it would look and how it would work. And then it was hit so hard by anti-flat earthers that they removed it, so it's only on Web Archive. But NASA treats it that way. We treat it that way. Celestial navigation always treats it that way. They only treat the stars as a static web of objects that never change distance, even though they think the distances are billions of light years away and independent. They're independently different distances all across the world. How would they use a web of different distance dependent things to navigate anywhere? That's retarded. No. They treat them all as a static web that moves with you, just like we do. So yeah, apparent is all we use, all we need, and all that's needed. So
Well said, man. Let's see if we got any questions or hands. If anyone has a question or can do a hand emoji, I'm scrolling through right now to see what's up. See what we got.
Got a couple of requests to speak I can approve here as well. Go ahead and
definitely some Globers out there.
guys up.
I see Bradley, Lathana, and Run Boston. That looks like they got their hands up.
I think Bradley was first, then Hana.
Bradley's a Glober, isn't he?
Yeah. As I look at one of the pictures that are on your model page, it looks to me like the sun and the moon are inside of the dome, the firmament. Is that correct?
How did you get that from this? Where do you see the firmament line that you can tell that the sun is below or above it?
Maybe I'm not looking at a picture that you produced. I can double check. I thought there was one. Well, doesn't matter. Just, is the sun and the moon inside the firmament or outside of it?
I don't know, man. It's a good question. I know that what we see is like an apparent version of that. Where the source is, I mean, that's anyone's guess, I guess.
Okay.
So wait, hold on.
Anyone's guess, I guess.
Yeah,
Hold
anyone's
on,
guess.
hold on. Hold on. So if the moon is in the firmament, right? According to some models that I've seen, then that would make landing on it a lot easier than we've been led to believe.
What?
Yeah. Does anyone else have any model? Oh, Liliana, did you have some questions?
Okay, or just ignore what I said. That's
Well,
we will.
I'll chime in if Hana doesn't mind me skipping her. I totally want to go.
All right, JT.
Okay, I'm not trying to be rude or anything. I mean, I know the elephant in the room is flat Earth is stupid, and obviously the sun, moon, and stars are really, really far away. But what we're postulating here tonight is that what mankind has seen since the beginning has always been apparent. Like the sun, moon, and stars has always just presented itself on the limit of our vision. And I know it's really confusing because people that are looking into the shape of the earth, they hear that we're inside an enclosed dome or a firmament of some sort, which we can't get to. Like we can't get to it because we can't go past the ice wall of Antarctica. If we could go, we'd love to, but like what's up in the sky, like what's up there, we don't know because we can't get to that part either. And somebody asked earlier, well, what is this azimuthal grid of vision? What is this perspective dome? And all that is, if you simplify it, is just human beings looking out into the world. So anytime you have a human looking around at the night sky, that is that person's personal vision, and it ends at some point. We don't see, 20,000 miles or 10,000 miles. We see 3959. Now that happened way before any theory of where we lived. That was going on with humans before anybody even wondered, well, where do we live? And the globe model was created by how we see the world. And what Shane's been trying to say is longitude and latitude was built as a system, and all maps that you've ever seen in your entire life are the same thing. The 220 conversions of the same map are like the exact same coordinate systems. And I'm not trying to be silly or anything, but why people are so interested in this topic is because obviously it's not a spinning ball in space. Some people still think it is. Some people think that that is absolutely the truth, but all measurements, all data, all looking into it shows that the Earth isn't moving and you can't find curvature anywhere. So we're trying to get into the ins and outs of how do we see the sun to each apparent, like to each person, what is it to them? Where is it to them? And like he said a second ago, oh, so if the moon, hold on, so 5 more seconds or 10 more seconds. So somebody said, well, if the moon is underneath the firmament, it'd be that much easier to go land on. But what we're saying is the moon is presenting itself apparently. It's not something that's, I don't think it's something physical you can go and touch.
Yeah, well, please explain how something that isn't physical has obvious craters on its surface.
Well, I would say right now that no one has been there to touch it, measure it, scoop it, take a picture of it. Like the scientific method, you can't do with these craters that you think you're seeing.
Well, which Jesuit name
Yeah,
crater were you talking about?
1
Hold
second.
on.
We're hardcore detracting into something that's not really the subject matter here.
Right.
So, but thank you, JT. That was an excellent explanation of the situation at hand. And as far as moon craters and optics goes, maybe you can catch that one on the next Ether Cosmology Twitter space, brother, when we talk about the moon landing when Demon Stride hosts it. So,
hold on.
Nope, won't be holding on. Is it model related? If it's not, then there's no holding on, and it's Liana's turn. Thank you, sir.
He is on his way out. Thank you. Like Alan said, come on back when we do the moon landing presentation, the Steel Man of the moon landing, brought to you by Demon Stride.
Nice, thank you, boys. Yeah, let's hear from Liliana. We have her texting all the time. We've never heard her speak. What's up?
Hey, can you guys hear me? Sorry.
Yeah. Yep. You're good.
Thank you. I have a question about the stars. And Shane or Alan or Toby or Ken or whoever, you welcome to let me know. I love watching these time lapse of the night sky with the stars. And I've noticed that in a lot of the like still photos, the stars, like you think, okay, this one star is making a line, right? Because it's captured so many of the time lapse. It's just a still photo of a time lapse. And so what I noticed was that a star will make a line, and of course, different stars will make, that curvy line of different lengths. But what I've noticed is that there rarely is it one cohesive circle from beginning to end that you can clearly tell that same star is making, because all the lines are different thickness, because it depends on the brightness, the apparent brightness, apparent size of the stars, right? And so my guess was that perhaps what happens is that certain stars go out of our field of vision, outside of our dome of vision, and then other stars come into our dome of vision. And so, that's the reason that they're not just all perfectly round circles. They all kind of break up. And to the naked eye, if you're not really paying attention, it just looks like circles, but they really are not. If you look at a still photo, you'll know what I mean, is that you can tell that it's not the same star making a completely round circle, even though round circles appear to be there, but it's really other stars that are picking up the anyway. So I hope I made myself clear, and I hope the question is, has some relevance to the topic being discussed. Thank you, and sorry.
I mean, Star Trail's time lapse is a function of a camera. First of all, it's not like a thing that can be observed. It has to be manufactured, right? So, first of all, that's one thing to point out. When you're doing Star Trails, they can't actually you put a camera out there for a short amount of time, and you hit the Star Trails button, and then it completes the circle, so to speak. But you said that you watch them as different lengths. I've never seen that. I've watched a lot of Star Trails. They always look the same width to me. But knowing that it's manufactured from a device could probably hinder that a little bit. I mean, I was always mystified as how they never interconnect. Like how when you do Star Trails, there's never an intersection. They're always in the same circuit, wheels upon wheels, as I think Ezekiel's wheels put it way back when. And that's something I think that ultimately brought me to Flat Earth for sure. So relevant, not necessarily, but super cool.
Thank you.
I have a question on the model, if it's okay, regarding the angular diameter of the sun, which is around 0.5, 0.53. Does the model, I haven't looked at the model in detail, by the way, so apologies. Does the model account for the 2 minutes that it takes for the sun to disappear behind the horizon? Roughly, it depends where you are, well, on Earth. and depending on where you are, it could be anywhere between 2 to 3 minutes. Does the model account for that, the 2 to 3 minute delay in sunrise and sunset, which of course has to do with the apparent sun and apparent sunset, right? Does the model account for that? I don't know. It's a question.
Shane, are
Shane?
you gonna, is your mic on or?
Muted on Twitter. You mean like the apparent pause between dusk and twilight? Is that what you're referring to?
I guess if you look at, I've seen lots of videos where they film the sun right before it disappears beyond the horizon. And my understanding, at least with the globe interpretation, is that because the sun's diameter is 0.5 or 0.53, and the Earth is rotating at 15 degrees per hour, when you divide 15 degrees by that angular diameter, that's how you end up with the 2 minutes. I was just wondering if the model accounts for that, or how does it account for it, for that delay? And also, it's a delayed sunset too, right? In other words, there's a claim that you're seeing the sun 2 minutes before it actually is visible on a sunset, and you're seeing it 2 minutes after it's actually set because of the diffraction causing the apparent sun to actually be in a different location in your eyeball than it literally is physically.
Mm-hmm. Interesting. Yeah, so that's from I think the dusk and the time difference between the north and the south, when people were talking about the Terminator line issue, how it wasn't exactly definite, and it became down to, and our argument was the south appears a longer dusk and a longer twilight than in the north. And does it account for it? Well, it uses timeanddate.com. So if we were using timeanddate.com to establish those discrepancies, then it would certainly be accounted for in this model.
Yeah, because I've seen videos, where I want to do this myself. I don't have a drone. I wish I want to get one. But what you could do is, if you have a really clear line of sight, like in the ocean, Hawaii would be perfect, because people have mentioned that there's very little refraction because the water temperature and the air temperature are kind of very constant. If you wait just for the sun to touch the horizon, right, and you start a timer, and you measure how long it takes for it to disappear, just go below the horizon. My understanding is approximately around 2 minutes, 2 to 3 minutes, depending on latitude. And also on the sunset end of it, that there's a 2 minute, because of the refraction, you're seeing the sun 2 minutes before it actually is where your eye thinks it is. And when it sets, you're actually seeing it 2 minutes after it's already set. because of that refraction. I just wasn't sure how that's handled in the model, or even if it is handled for that matter. But you can do it with a drone. What you do is you wait for the sun to set, right? And then you take the drone up really high again until the sun appears again. And you get it to be right on the horizon again. And then you start another timer and you'll see it'll be 2 minutes. You go up another, I forget how many feet, but you could get it to do that multiple times. And it's always about 2 minutes or so, depending on where you are in latitude, is my understanding.
Right. Well, then that wouldn't work here because this only uses one height and it's sea level and it doesn't go very much above that. But it would use everything from timeanddate.com, which interestingly, when portraying the sun, has to draw a azimuthal grid around each observer and then parade that grid around the map so that it can properly account for the sun's path and the sun's light, etc. So it's using the same thing as we're using essentially. Yeah, we got a lot of people here. There's 100 people in here. Who else wants to ask questions?
We had a question from an ionized cat in the chat. wanted to know if it was possible to swap out the map in the model because it would be cool to show other map displays.
That is a good question. TBD, to be determined.
When are we going to get an expansion pack to the model where we can use modular map systems and stars, etc.?
Dude, I'm
how about the video game? You guys got a Blender, dude. Now we could do a video game, right?
Oh, that's right.
Well, we just brought up Bert Pasquale, I believe, although... No, yeah. Are you here, Bert? You have a question by any chance?
I think we can rotate JT's mic out too. He's going down for the night. Oh no, he said he'll be back. My bad.
Good. We love JT. That's the mayor of Flat Earth, in case you guys didn't know. We got to treat him with respect whenever he's here.
Yeah, in case you guys weren't aware, he is the mayor.
No, great.
All right, someone's mic, it sounds a little rainy in the background, a little staticky. So if you could mute while you're waiting, that would be preferable. But I think you did say you had a question, so go ahead and then make sure you mute up when you're done.
Am I coming through okay?
Yep.
Oh, hey, excellent. Hey, yeah, I just met Shane the other night in Clubhouse, so nice to see you again. And I was listening to what you were talking about earlier about that parent position, and I just wanted to steel man that for you a little bit. A few years ago, I designed a camera that got installed on the Keck telescope in Hawaii, the big one of the big 10-meter telescopes.
Is it
part of the optical design?
All right, go ahead. Can you move your mic a little closer?
Hold on.
You are coming in really broken up, brother. I had to switch to headphones to get a better signal. Something about the speaker on the Android that hoses when you don't have headphones.
Well, I was actually using ear pods, but is this any better?
Much better.
Way better. Oh my God. Thank you. God bless.
Right. Yeah. Thank you. Yeah, I just got rid of the ear pods and just speaking straight to the phone. Yeah, so I worked on a optical design for a camera that got installed on the optical bench at the Keck Observatory in Hawaii. There's the dual big 10-meter telescopes up on Mauna Kea at 14,000 foot elevation. And one of the really interesting things is that I had to put in what are called atmospheric dispersion correction prisms into the optical design for the camera. Because what happens is if you're magnifying something, you're looking at it off at an angle through the atmosphere, not only is there a slight apparent position difference from the actual angular position that it would be, but it's slightly different for different wavelengths, and in essence the atmosphere is acting like a big prism, and you get a red fringe on the bottom and a blue fringe on top of whatever you're looking at. And so there's actually some prisms that you rotate and cross disperse to anti-disperse the atmospheric effect. And so these atmospheric dispersion prisms have to be used judiciously to correct for that chromatic dispersion. And the effect goes from no effect if you're looking straight up, because then it's like you're looking straight through like a plate glass window, to a very strong effect if you're looking off near the horizon, because then you're looking at like you're looking sideways through a plate glass window kind of thing. And the total effect was such that near the horizon you could get almost half a degree of angular deviation from the actual position. So what you were saying about apparent position versus actual position is correct. And just to quantify that, it increases rapidly as you get down to the horizon to a maximum of about half a degree deviation of apparent versus actual, which I think was the same thing that was just being discussed about, that the sunset happens about 2 minutes, 2.5 minutes after the actual sun would have gone out of field of view. And this dispersion is a smaller effect than the half a degree, so just a couple arc seconds. But that's about it for the power of atmospheric dispersion.
Well, excellent. Thanks for sharing that.
Yeah, thanks for putting some numbers on it, man. Appreciate it.
Sure. And even amateur astrophotographers who have like maybe an 8-inch Schmidt-Cassegrain telescope, if they're really magnifying like Jupiter or Saturn or something, they'll even use commercial atmospheric dispersion prisms to get rid of the red and blue fringing. Tying that into the topic of the room, as I've kind of like poked around a little bit more the past few days, even with the flat Earth model, I'm interested to how Shane, how you would answer the kind of overall question. In the what's it called, the personal sphere that moves with the observer, personal celestial sphere. I forget
Yep.
how that's
Yeah,
phrased.
your azimuthal grid of vision, your personal, just any word, any verbiage you like,
Sure.
it's fine.
Right. So as I played with that for different positions on the globe and such, I was struck by, like, if I move the time of day around and let the sun go around and watch the sun project onto that personal vision, and if I turn on the stars and then do the same thing, it's interesting that that personal vision is kind of the same motion derived from a heliocentric model, but then it's actually works out that in the flat Earth model, that's what you get in your personal space. And my question is, what's the mechanism for that? That it converts the flat Earth model with the sun moving around and such, and the stars in the dome. What's the mechanism that actually makes that work? Thanks.
You there, Shane? I noticed it looked like you had dropped. I can't tell if you're bugging out. You can hear me, right, Alan?
Yep.
Okay. I'm not sure if Shane. I'm gonna try and invite him back up again. I'm gonna cancel his co-host invite and then re-invite him. But to answer your question, the mechanism is perspective and the fact that you can't see forever, essentially, right? Shane, are you back? But so essentially, if you think about it, as something moves away from you, it gets smaller, and that's because it's moving into a wider field of view. And as something moves into a wider and wider field of view, it's going to get smaller and smaller and smaller because you're taking in more information your resolution is going to shrink as your field of view grows. And so then eventually you're going to hit a point where something has shrunken out of your field of view. It has compressed so much that it's gotten to a point where it is no longer resolvable at all. It's like being less than a pixel on your monitor, or like less than a pixel on your phone screen, right? Like once you get down to that point, once you go below a pixel, you have nowhere else to go other than to just disappear from vision. And so that's what things do as they come in and out of your field of vision. But then to add on top of that, you have to think about the fact that you're standing on a plane. So everything you see in the sky is a plane above you at a great distance. But then but where you're from your vantage point, it looks like we do have Shane back, but let me just finish the thought. From your vantage point, as those things rise and come above you and then set beyond you, what's actually happening is just that you are standing on one plane and you're looking up at the other plane, and it's coming into your field of view, and then it's above you, and then it's sinking out of your field of view. And if you think of train tracks, the way that they converge in the distance, essentially you would just take those train tracks and turn them on their side, and then that's how you get your horizon. Essentially you'd have those train tracks converging, those two planes converging in all directions around you, except that you're standing directly upon one of them, so you're limited, especially to that line. Your dome of vision is limited by the ground beneath your feet, essentially.
Okay, I mean, thanks for that. That kind of gives the explanation I've heard before about the perspective, about the things disappearing at the horizon and such. But my question is going a little bit deeper. I'm asking maybe a PG-13 question here. As I studied the flat Earth model and I was looking at that personal sphere and moving the time of day around and such, I was seeing how the sun is projected onto that personal sphere and moves around that sphere at a constant speed. And I saw how the star fields are projected on that personal sphere and move around at a constant speed, which of course is what heliocentric models would say. Well, of course, because the Earth is spinning at a constant speed and everything is at a great distance, and so you see it move around at a constant speed and at a fixed angular relative position to each other. So if in the flat Earth model, that is what is apparent within the personal sphere, what is the mechanism to make it happen that way when they're distributed over the dome, not in that way when the sun is going around in an angular way that is not constant to that angular space in the personal sphere? Why, in other words, why does it match up to the heliocentric spinning Earth field of view, perspective, but it happens on the flat Earth? That's my question, I guess. And is there a mechanism to describe that bending of the rays to get that?
Are you asking in terms of the model or in terms of reality and actuality? Or both?
I mean,
I think he's asking for both and about the bendy light rays, it sounds like. So Shane, if you want to give a quick rundown on that.
So like observations of the sky are not heliocentric exclusive. When you say it matches the model, you mean it matches observable reality, I presume, because that's all we ever see. Of course, the globe model was built based on observable reality, and particularly built upon the observations of the celestial heavens, right? When they discovered a Polaris elevation equals latitude in the northern hemisphere, of course, they would use that, right? So when you're saying it matches up constant speed, well, 15 degrees per hour is, of course, what we measure, give or take, with interferometry at a higher level to show the actual movement of the sky is about that at average. So when we say, hey, that matches it, can we say it matches heliocentric model, or do we say it matches the observations from which the heliocentric model was drawn? What else did you say about the bendy light rays? Essentially, Mr. Walter incorporated specifically for this map projection and not the other 201 map projections. And for this map projection, when you forced the actual observations of daylight patterns onto it, he thought that it required these superfluous bendy lines to make it look retarded, whereas the other maps displaying the same light pattern wouldn't need said retarded lines. However, this one definitely needed it. Now, essentially, they're just there for no reason. They serve no purpose. They do nothing. They don't infer anything. They don't show anything. They're just superfluous bendy light lines to show that we don't understand light distribution or a coffee cup caustic effect.
Now that you mention bendy light, the the curved visual space. Can you explain how you see how you think the curved visual space is a factor with for example stars over 70 degrees? I find this argument pretty great because it's against the globe, and so why do you think it's yeah, I would like to see it visually. Maybe it's not possible to show it right now, but you think it's that we see like curved when we look up, yeah, and that's why we can explain it. So there's a little bit of a curved view when we look up. You mean, yeah?
What?
Yeah, 100%. So if you can click on Shane's name, right, like on Twitter, you'll see that he's streaming. If you can click on that, you can see the visuals that he has for it. So what he was asking Shane was, you know how the vision scales, what is it, logarithmically at past 69 miles or whatever?
Oh,
That's what he's asking about. So if you could,
okay.
yeah.
Let's see here. There's a lot of visuals to go through. Look at all them. And it's right up here.
There's nothing like the sound of a good mouse wheel turn, honestly. Like I'm
You
not
hear
into,
that?
I'm
Boy,
not
that's
into,
far.
dude, I'm not into ASMR, but like if I like hearing that mouse wheel turn, like I don't know, there's something about it, man. It's just very soothing.
All right. So from the spreadsheet that we drew up to do the 69 miles per degree of the personal celestial sphere with the enforced limit using the unit circle, pause, we discovered that this essentially is the answer, right? Can you guys see this? Yeah, you can. So we graphed it out, and it has a linear basis, essentially above 20 degrees and below 70-ish there. If you didn't know, you would, you weren't using a linear function, you'd think it was linear. All the elements would be linear. Literally, the difference would be negligible until you get past a certain point. So past 70 degrees, where it levels out there, becomes nonlinear, or approaching the limit but never reaching it, something like a logarithmic, but not with the actual value. So what we have then is the linear portion, or a logarithmic function that is linear for a main portion, the linear portion of which you're only allowed to use. And when you don't use it, when you do use it past the threshold, they give you these giant correction tables, which themselves scale logarithmically to approach infinity. So the closer you get to 0, the higher correction you have to make. The closer you get to 90, the higher correction you have to make. Now, good old Bacon, our good friendly Glober, did let us know that you can do it above those thresholds. They just recommend highly against it. Fair enough. Thanks, Bacon. But you said, how does the non-Euclidean visual space occur? Well, essentially, what they deduced from, let's see, the alley experiments was that, you would see, and they applied geometry to it, that you'd see in the far field differently than in the near field. And I would think they went parabolic to hyperbolic to was it linear to parabolic to hyperbolic at extreme range. So they essentially denoted the near and far field as different geometric expressions. And then we would say that sort of fits with something like this. If this is the near and the far field distribution, then they allow you to use the linear portion, or where you would see it linearly, essentially.
Awesome.
But aren't the stars? Don't we always see it on the edge of our vision? That's why I want to make a real life model also, because for the sun, that's clear for me. For the stars, I'm not quite sure. But like the main criticism, what I heard is like, how can some light from outside project on our edge of vision? And so I would like to make a real life model with a smaller lens than our eye is, that, and then we could shine a light from far high up on down to our on the edge of this lens, and then we could prove this concept, or we could do something like with fog light to dim the vision, to also do this. But the small scale lens would be an idea for a real life model. Or have you thought about real life small scale models of to prove your model?
No, but there are other models that already prove the light distribution thing, right? There's a nice one from I think the Sun Never Sets one, where the reference to the angular resolution video and document that literally shows a demonstration of a local light in a warehouse being moved, along a flat warehouse floor all the way to the end, till the light that it sheds becomes literally indistinguishable and unresolvable. Or, as we discussed with our PhD friend last night over at the Clubhouse app, if you have a car at night with headlights, you won't always be able to see those headlights. They will go far enough where they will become unresolvable and you'll be unable to see them, right? That's the limit. That doesn't mean they went over an Earth curve. If you're looking at a desert, that means that they became unresolvable into the darkness. And the same thing happens with the sun.
Yeah, it would be cool to play around to see at which distance you have to, where you have to circle this light to make it equal the same size, and this just an idea to when you have a very tiny camera lens, you could decrease the edge of vision in an eye. So I would like the calculation how far out you have to go. This would be easy with your formula. If you have the tiniest camera on what's technically available right now, then you probably only have to go like a couple dozens of meters up, or and you could already, maybe a couple of miles you have to go. To have a real life model would be good to play around, because when I share this domes and with a flashlight above, you don't always see it completely equal, this light, and so there's always critics of this, how you think you can make this light really same size, or at least put the camera in this inside of these bubble glass things, and look at how we can make this light same size. But it's just future projects.
I'm down. We need more projects and more experiments and more proactive flat earthers, man. What else we got?
Yeah, thanks for sharing your thoughts. Anyone else have any questions or thoughts about the flat Earth model, Shane's flat Earth model?
Yeah, I had a follow-up question if I could. This is Bert.
Sure, go ahead.
Thanks. So when I mentioned that the star movements would match that of a heliocentric, spinning globe, and Shane, if I understand your reply was, well, of course it matches. They made it match the observations. So I think we were in agreement that a spinning globe would give the same view. But my question is still this: in the personal space, it gives that star field, the sun moving in that view that matches the heliocentric model. But I'm still trying to see what would the mechanism be that would transform the sun's going around over the flat Earth and the star field. What mechanism transforms it to match that constant rotating around for everyone's personal space, because everyone's tilted a little bit different depending on where they are, longitudinally, latitudinally, and the star field, the way the light would get from the positions on the dome versus the positions of the sun, which is moving around inside the dome. There's both those are like two separate transformations, but they have to overlap. And so I'm just trying to see, do you have an explanation of what that mechanism is to make it look like the view from a heliocentric spinning globe?
Well, let's ask you a question, man. How would it look like if you lived on a plane with a viewing radius of 3959? How would that differ from a globe that you think you live on?
Explain that question a little more. Sorry.
Yeah, so you're asking all these questions comparatively to your mental idea of what it would be on a flat Earth, hence why you need these mechanisms that are self-evident and explanatory. So, like, how do you think it would be different if Instead of on a globe, you lived on a flat plane with a viewing radius of 3959 around you. How would it be different?
I guess what I'm trying to match up in my head is
it would be identical is the answer, right?
I'm sorry, what?
It would be identical is the answer, right? That you didn't answer. It would be identical.
No, I don't see that it'd be identical yet. I'm not there. So if the stars are fixed on the dome, right? And that dome rotates every 24 hours, right?
4 minutes slower than the sun sidereal time, yes, sir.
Uh-huh. And the sun goes around. I don't know, you say the height of the sun versus the height of the dome, etc. The different people on different positions on the flat Earth would see the sun relative to the star field differently at different angles, so to say, different perspectives, different parallaxes. And the same for the moon. And same for the moon. Right. But they would be very different, it seems like. And I'm trying to figure out how how your perspective to these objects going around over the flat Earth versus the objects on the dome don't have radically different parallaxes for different people, say in South America versus North America versus Australia on any given night. Does that make sense?
No, but I don't know where you're getting that. Some of it's in the firmament established in a thick, and some of it is rotating freely above us. Like, we didn't declare any of that. We're just saying everything is up there, and here's how we observe it on the ground. So I don't know where that basis comes from, man.
Well, I'm just saying, like the heliocentric model, the moon's what, 250,000 miles away, and someone in North America and South America observing it simultaneously can triangulate it and kind of get the angular difference and say, okay, well, that makes sense geometrically to the heliocentric model. But someone in North America, South America on the flat Earth, if the moon is, say, above them halfway, they're looking at it at radically different angles because it's so near. It's a near moon, right? And so the perspective of the star field projected out wherever it is on the dome, beyond the dome, I'm not sure. It would be like the moon would be in a radically different place. Like if there's a screen behind, if you're looking at a TV screen and there's an object between you, but there's someone to your left and someone to the right, they would see that object very different places on the TV screen behind them because the TV screen is close and the moon is close, the object is close. Do you see what I'm saying? There's like a parallax that I'm still trying to work out. How does that work in a flat Earth model?
Parallax? How does parallax work in a flat Earth model? Is that really the question?
For the moon versus the star field behind it.
Well,
and why isn't it radically different for people on different parts of the flat Earth?
I mean, the moon local being parallax. I mean, that's a crazy thing you're throwing around. You know, there's like a rocket.
That's a completely legitimate question.
Yo, please don't interrupt.
Sorry.
Shane, what were you saying? You know what? I think he just crashed out. His computer just crashed out. So while he's rebooting,
sorry.
Yeah, you would have to get into, so the sun and the moon are the same size, right? So the distance derived for your parallaxes would be the same. That's the conundrum that Red's rhetoric has been in since Jaron pointed that out to him like 6 years ago. Like the Parallax measurements for the globularist have assumptions built into it, which confirm the globe when you look into it, but it's all based off of angular size. So it doesn't really prove anything one way or another when you realize it's all apparent anyway.
Well, I'm not talking about the size of the moon. I mean, that's another issue, is that you're at different distances on the flat Earth versus a far away moon of 250,000 miles. But I'm asking about like I've seen videos where someone in North America, South America, they both take a picture of the moon at the same time and then they send them to each other. And the moon is slightly different position relative to the stars. And that works out to the angle of the distance of like 6,000 miles versus 25,000 miles, 250,000 miles. That small angular distance matches the heliocentric model. But if on North America, South America on the flat Earth, and say the moon is above them, say near Central America, right? they're looking at them radically different angles, like 45 degrees to the north versus 45 degrees to the west, to the south, and the star field behind each one of those views would be completely different. You know what I'm saying? So I'm trying to figure out how that would work in a flat Earth model. That's not really. I haven't seen a mechanism in that, and I've been playing around with the website a little bit, and that I can't quite figure out how that would be addressed.
Well, that's a model, right? It's not going to address the function mechanism for reality. I mean, it's going to do the model. It's going to do the JavaScript portion, which would represent, the microcosm of whatever effect we're trying to emulate. However, my OBS crashed. Did he elaborate on his question, or are we still?
Yeah, so his question was about parallax and the moon and how you can have two people in different locations in North America take pictures of the moon and triangulate their distances based off of the apparent size of the moon.
Well, I'm saying like from North America or South America, the star field behind the moon, like where is the moon in the stars, right? It's not very different, but it's a little bit different, and that matches if you're like say 6,000 miles apart on a globe and the moon was 250,000 miles away. But I'm trying to figure out how that then matches if you're 6,000 miles apart on the flat Earth, the moon is 4,000 miles or however many above, but radically different views of angle of views. Then why isn't the star field behind it radically different? Because you're kind of looking at it from different perspectives. Does that make sense?
No.
So is it so it's like let's say you're looking at a big screen TV, or better yet, a movie theater.
Well, how about better yet? How about, because you already kind of explained it. I do follow, but I think this would be better if you just provided your source about the triangulation so we could look at that, right?
Okay, I'll find it. Give me a minute.
Well, like again, this is assuming that everyone knows the distance to the moon, right? But there's a wonderful observer when they launched the rocket in Arizona, and they could see the moon clear across the flat Earth, and would have been right through the bottom of a ball over New Zealand. So if we can see the moon from Arizona when it's over New Zealand, what does that say about the distance that you think it's at? Anyway, the apparent is all we ever use. So when you're saying when we triangulate, that's a crazy thing to assume, because all the globe did was move those distances that wouldn't match up for any observer to a near infinite distance, so that they would in fact match up. But those vectors don't actually solve any equation. That's just like a mathematical cop out. So, but I mean, like, would we be able to see the moon when it rises? Of course. Well, I don't understand why you think we wouldn't. Or I don't understand what you're looking for, to be honest. Even though I do like you.
Yeah, I do too. But he's hung up on the triangulation and the distances, though. Like once we get over that hurdle, he'll be set. But anyway, Oh, sorry. Did you have anything you wanted to add on to that before we move on?
Yeah, I mean, again, my question is just how does the field of view change? Let me just finish this one real quick analogy, and then you'll understand at least what I was asking, and maybe in future conversations we can come back to it. So if a movie theater is just showing a star field on the screen, and then someone puts a balloon up in the 5th row, and you're in the 10th row behind it, you see, you take a picture of the balloon. It's in a certain position relative to those fields, but someone to the left of you and someone to the right of you takes a picture of that balloon, and it has completely different set of stars behind it, because
Yeah, parallax relative to the stars. We get
Right,
it, dude. We get
right.
it. Linear parallax relative to the stars. We get it.
Yeah. So how does that work out in the flat Earth model?
Well, I don't know if you were
Really
here
different.
earlier when we talked a lot about apparent positions in the sky. I talked about Aries failure and how the stars aren't even in their actual positions. We see them in apparent positions, and about how there's multiple layers of the atmosphere, even in your model. And in your model, the multiple layers of the atmosphere have reversing refraction rates going up and down as you go through the different layers. So everything that we see in the sky is objectively in an apparent position. So your assertions about matching the heliocentric model really don't mean much, right? Because we already explained that everything we're seeing in the sky is apparent. Now, if you wanted a mechanism, I can spitball you one. It's based on Hildegard's model back from, I want to say, the 1600s or something like that. Hildegard proposed a geocentric model. It wasn't a flat Earth model, but it was a geocentric model in which there were multiple layers of ether wind, and that's why the moon and the stars and the sun have different levels of aberration, and that would explain why you would see different layers of you would see what you would describe as parallax due to that, but really it's just different indices of refraction, right? Different ether winds, ether flows that those objects are in. So that would be a mechanism to explain that, of which we could come up with a bunch more. But it's kind of just a bunch of guesses about what's in the sky, which I personally don't like doing a lot of.
Okay, yeah. And by the way, I was the one who earlier mentioned that you do get a dispersion effect as you look closer and closer to the horizon. But that the refraction and dispersion is almost negligible looking up, or say off to about 40 degrees off from up. And even down to the horizon, the cumulative effect of any of those layers of atmosphere, or if you call it ether or whatever, only account for about a half a degree of refraction downward.
How are you
But
possibly going to
up
make that assertion? How are you possibly going to make that assertion? Based on what?
by following the movements of the stars if they're a constant speed.
So you're making
And
assertions about where the stars actually are by measuring their apparent positions. You're just using circular logic here. Let's go.
no. What I'm saying is this: they're constant when they're up, and then you see them start to slow down a little bit at lower elevations, and also you see the dispersion where the red and blue separate a little bit.
Yeah, so
And
that's going to be
makes sense
related to the logarithm, the fact that it goes from a linear scaling to a logarithmic scaling as you come into the horizon, right? And that's which makes perfect sense because you're getting into a nonlinear drop off as things converge out of your field of vision, right? As those things are getting further away and sinking into the horizon, that drop off is going to be nonlinear.
Sure. Yeah, I think it's actually more of a sine effect than logarithmic. But yeah, you get a. But I'm agreeing with you. But I'm saying the cumulative effect of any of those layers, of any of those indices, is at most half a degree near the horizon, but it doesn't deviate the constant angular spacing between stars. So like you can look at star A, star B, and say they're 1 degree apart, and as they get lower and lower in the horizon, they don't really change that 1 degree. It's a very constant angle until they get down lower. Then they might start to compress together a little bit.
Yeah, but okay, so we're going in a circle again because I've already explained, right, that we're gonna have we're gonna have different layers of refraction. It's gonna be a different you're going through multiple layers of atmosphere, and until you can go up and measure what that actual thing is and what that actual distance is and what you have no expectation, right? There is no expectation we can provide without knowing what the what that physical thing is in the sky and how far it is and through which medium it is being observed.
Well, I would submit to you that angular positions relative to one another are a way to measure the effects of whatever those layers are.
They're a way that we can observe
Yeah.
them, but then to
Yeah, sure.
try and make deductions about what
Well,
the material makeup of those things are, and anything more, any assertions beyond angular size and observed luminosity, any assertions beyond that are just stabs in the dark, and you could compute them in a multitude of ways that are utterly meaningless.
Well, I would submit to you that they're meaningful if you can model it, say, using Snell's law and the properties of what we know about air, for example. And those modelings work out really well.
Well, that's an
For seeing
assertion.
both the.
I mean, some of them
Well,
do,
I'm saying
sure.
they do. I'm saying they do as far as like the distance between angular ratios between stars as they
Yeah, and we could
move,
change a few of those
and as well
variables.
as
If we changed a few
the
of
red
those
and green.
variables, we just have to change a few of the other variables, and then that's why even in your model, right, they've changed the distances to the sun and the moon numerous times because all you have to do is adjust the scaling. It's utterly arbitrary. That's kind of the whole point of this whole thing, right? Is that we can take your sky model and map it to essentially any map that we want because you're just looking at kinematics of observations in the sky. And to try and make assertions about the physical makeup of those things, the physical size of those things, and the physical distance of those things, it's not fruitful. So yeah,
Okay. All right.
looks like Shane bugged out. Let me get him back up here.
Yeah, all I was saying is that it's a good measurement of the overall. You can measure the overall effects. That's all I was saying, regardless of what the actual materials are.
Yeah,
But
no
you got
worries.
what I was saying, right? That if you change one of those variables, all you have to do is change other variables. And it's if you're making stabs in the dark about material makeups and sizes, then it's not very fruitful.
Well, no, it's not stabs in the dark to say we have very accurate measurements of these things.
I think is he roboting for you as well? Anyone?
Dude, yeah, he roboted, and also I'm gonna leave real quick and rejoin because what's it called? It's memory leaking or whatever.
Yeah, and I don't see Shane with a request up actually.
Oh, cool. You might be cool. We might all need to reset.
Here we
I'll
go.
be right.
Here he is.
Nice.
Okay.
All right, I'll be right back in a few. Actually, can you take my co-host first, and then I'll do it?
Oh yeah. Let's see.
That way it'll be easier.
Boom. Shane, are you there? Testing.
We'll play this. I'm gonna play this video at the end here. We'll keep that on bookmark. Close. All right, here we go.
Shane, are you there? Testing. Hey, there he is. What's up, Shane?
OBS crashed, which I guess now means sound dies from this Twitter space. So I would have to require a rejoin. Jeez.
Ooh. All right. So we had a question from is it B1B? Is that who B1B Lancer?
Yes.
Is that who?
Was it from our debate?
Yeah.
Yes.
Yeah.
This is the
hey, man,
pilot
welcome.
that we debated.
Yeah.
Yeah. Welcome. Thanks for showing up.
Oh.
Did you see the video of the flashlight or the local source from the warehouse becoming unresolvable on the flat plane as it goes away?
No, I have not. But regardless of forget the warehouse. When the sun becomes unresolvable, is it supposed to be dark then?
Well, it gets dark on flat Earth, right? It's something that we know. So that
Okay. Well, yeah.
if the sun were to go away, then yeah, it would be unresolvable. It would be dark then.
Okay. How come it's light after sunset?
You mean what is twilight and dusk? Well, if you think about what daylight is, and it's actually, ionized gases in the atmosphere, argon fluoresces blue, things like that, hydrogen, helium. What you have around the sun is an electromagnetic field, which would ionize the gases. And when it disperses and becomes no longer visible, its daylight field is still visible for a little while longer, right?
So you're saying twilight is because of ionized gases in the atmosphere. Do you have any
that's daylight.
documentation for that?
It's daylight, yeah. Documentation.
And if the sun is, how come the sun? If I watch a sunset, the sun doesn't get smaller. It's not fading to a point. It's the same size. Why is that?
Why does the sun never appear at different size? Well, if it's never any further or closer away from you, it would probably never change angular size, right?
Well, now you just said that sunset is when the sun goes in the distance and becomes unresolvable.
Mm-hmm.
If it does that, shouldn't it get smaller?
No.
Why not?
Why do you think it would get smaller?
If something is way off in the distance, doesn't it appear smaller than if it's close up?
This is like when the sun comes by, it should rocket past me overhead. It should just zoom right by me. How come it doesn't do that? Right?
Why would it do that?
Okay. Just want to make sure you're not one of those people. You don't think the sun should do that then on a flat Earth?
Huh? No.
You think it just should change angular size?
You said that the sun at sunset, the sun goes way off in the distance. Well, if something goes way off in the distance, it should appear smaller. So how come the sun's not smaller at sunset?
Well, I mean, you know that you have flaring, glaring, lensing. It does appear huge as it comes and then goes smaller as it goes away, but that's all an effect of the glare or the light as it becomes more glaring and less glaring as it comes and it goes. If you put a nice little solar filter over that, though, the tiny little dot of the actual sun would remain more or less the same, aside from the changes recorded on timeanddate.com every day and over the year. Of course, it does change every day and over the year. That's recorded there. However, if you want to just say that doesn't exist, then why would that be? Well, that's because of what the sun would be, right? The sun and the moon have the same effect in our local local visible dome there because they never change their distance from you. They always are appearing at the same distance. That's all it is, man. You can only see it
well, if they're always appearing, okay. Well, if they're always appearing at the same distance, then why are you pointing to the flashlight on the warehouse floor that when you take it really far away, it becomes unresolvable? Well, which is it? Are you taking it very far away?
Well,
real
or
quick,
is it always
to
the
show
same
you
distance?
the other example you brought up, which was, how come it doesn't ever get dark, right? And it's, well, it does get dark. And as you can see in that example, here's an
I
example of a
never
light
said it
source.
didn't. I
Well,
never said
real quick.
Light source moving away, so not be dark.
Real quick,
I
right?
never said it didn't
There
ever
is
get
an
dark.
example. Speaking of the factory floor, like there are examples that you can do to actually show something sinking out of your field of view without losing angular size. But the sun does actually change angular size. It's just maybe less than what you're expecting. But it does, which Shane did point out. But yeah, we have examples of pulling something away from a camera on a floor and then or on a table, and as you pull it away, it actually sinks below the horizon. And that's just because of
No, pretty sure it doesn't.
that's just because of your relative position to the ground, which I was explaining earlier, that when you're standing on a plane, half of your sphere of vision is blocked by that plane, right? And then actually more than half, because the land in front of you or whatever is in front of you is obscuring. It's going to obscure things depending on the angular, depending on if something is rising above your eye level or whatever. But then also things are going to converge into a point, into a blurry horizon where the sky appears to meet the ground.
The sun doesn't appear blurry at sunset. It's quite distinct.
Maybe
Well,
you should look
sometimes
at
it
one
actually
in the desert.
diffracts above the horizon line. So
No, the sun doesn't. I mean, you're giving me contradictory things. First of all, you said the distance inside the dome never changes, but now you're
Well,
saying
you're scattergunning different questions and topics. That's why we're giving you different answers. We're trying to
no.
answer
I'm just repeating back to you what you said.
Would you like to see a sun that gets smaller?
Well, according to you, that's what should
I'm
happen.
just asking you a simple question. Would
Yeah.
you like to see it? Okay, there are desert shots of a setting sun to where it goes to a pinpoint, but the air is dry and the land is very flat with practically nothing in your way. And you can see these videos and it actually drops in angular size. But you can go to the beach and you can watch the sunset and it actually appears larger as it starts to set. So it depends on where you're at, atmospheric conditions, how much moisture is in the air that you're viewing the sun through. It's at a much lower angle in your field of view. So yeah, there's lots of things to consider.
Yeah, there's lots of things to consider. Like, for example, when you said the sun's going to pinpoint, is the video actually showing the sun higher up in the sky and following it all the way down? What kind of a camera was used? How far was it zoomed in, zoomed out? Was it wide angle lens, telephoto? Yeah, there's lots of things to consider. You're right. But I've got one other question. Is that why are the constellations in the southern hemisphere completely different than the northern hemisphere?
They all go east to west. What are you talking about?
I'm saying,
well,
the smaller and larger Magellanic Clouds, satellite galaxies in the Milky Way.
Some are visible from the north, some are visible from the south,
hold on,
right?
let
They depend on the season.
Let me finish
They
my
depend.
point.
Okay.
Let me finish my point. Smaller and larger Magellanic Clouds, the satellite galaxies to the Milky Way, they're not visible in the northern hemisphere. They are visible in the southern hemisphere. The Southern Cross constellation, only visible in the southern hemisphere. Why is that?
Are you done?
Yeah.
Okay. Yeah, no, constellations are visible independent on where you are. They're literally, because of the sky is so big, right? If you're north of the equator, you can see a different portion as when you're south of the equator. That portion, that part because you can't see forever. You can't see infinitely. Distance doesn't scale infinitely when you're from your linear perspective. Just to start with, right?
Hey, real quick. we're gonna let you finish your thought, B1B or whatever, and then
Yeah.
and then we're gonna dip you out, dog, because we're kind
Well,
of derailing here
of
and
course
talking
you are.
about something that's not
Now,
related to the
wait a
Well, I
minute.
subject.
Now,
think
hold on.
we should
You can
probably have
fix-
more spaces like this, is what I'm figuring out, so we can talk about all the other stuff that everyone wants to
Yeah,
talk about. But this one was
Okay.
supposed to be for this specific.
Yeah,
But
well,
now
model.
you're
no, we'll
saying-
definitely listen, guy. We're gonna let you get your final thought out. Then we're gonna
Okay.
rotate you out. When we do another
Okay.
space that's more generalized, we'll definitely come back to this. This is supposed
Thank
to be model specific. We kind of derailed a little bit, but we're getting back on track so we can move on or wrap up here.
Okay. All right.
You're
that's
definitely
fine.
welcome when we have it open for that. Absolutely.
Okay, that's okay. My final thought: you're saying that no, you can't see infinitely. Obviously not. But you can get a really powerful telescope. Are you telling me that with the largest telescopes available from the southern hemisphere on a flat Earth, you couldn't point it to the north and see the constellations that are visible with a naked eye in the northern hemisphere? That doesn't make sense.
Well, I mean, it does for a couple of reasons, right? First of all, telescopes don't make you see further; they just increase things that are unresolvable. So, like, they make your resolvability so that your angular resolution resolvability more, so that things that were unresolvable become resolvable again. It's not that they weren't there; it's that you wouldn't be able to resolve it. That's what a telescope does. Second, you don't see all of the sky. Not everyone sees all of the sky. On flat Earth, if you only see half of the sky, then half of the sky would be invisible. Well, the same reason why it's night and daytime, right?
But
half of the sky's in night, half of the sky's in light. What do you mean?
If I'm in if I'm in the southern hemisphere and the constellations in the northern hemisphere on your flat Earth, it should be visible.
Well, no, you can't see.
This is supposed to be final thoughts. So if you want to
Well,
wrap
that's my
it up.
final thought. But thanks for not answering my question.
Well,
You're very welcome.
Well, he answered it, and then it led to another one, which leads to another one, which leads to another one, which isn't the purpose of this space, sir. So thank you.
Okay.
Thank you. All right. So anyone else have any questions regarding the model or the objects in the sky?
Did you want to do a quick...
To be fair with B1B, understanding how optics works is kind of like prerequisite for understanding this model. Now, but I would also say that, we have literally like 5 videos all about the topic of optics. It's a very, if you want it to be, it can be a very deep topic that we can go into, but just understanding the way that something that we can't see forever, and that if you like on a plane, in a plane Earth, a planar Earth with a planar sky, the fact that they would literally do what we see, especially as Shane already submitted, that we see in a radius of 3959. Like if you can't steel man that position, the fact that seeing in a radius of 3959 would make an apparent globe, then I would just ask that you go, if you're looking for us to point you to some resources, we'd be happy to do it, and then maybe come back when you can steel man that position, and then you can point out to us the flaws in our position or something along those lines. But to just try and derail this whole conversation into it, some of us get it, some of us don't, and I don't fault anyone for not getting it. But just try to do the thought experiment at some point. Try to actually steel man our position before you come in here and argue with us.
Also, he's always welcome. That dude was our first debate foray, and I think that was a structured format from which to be introduced. But you're welcome to come have cordial discussions all the time, man. Definitely.
Yeah. Although I didn't like the way he would like interrupt you while you were talking, but we can work on that.
Let's do the Southern Cross real quick, since no one's asking about it, and it's kind of what we want to show you, right? There's the wonderful observation of the Southern Cross from 3 southern continents at the same UTC. Right? Everyone's familiar with what I'm talking about? Maybe questions?
Yeah. So I'm sorry. Say that again. So you're setting up a Southern Star Cross from 3 observation points, and then how are all the observers looking in different directions on the globe and or flat Earth? Great.
Yeah, one of my favorites.
All right. While you're covering this, I'm going to be AFK for a second. So.
Yep.
All right. Go ahead.
Let me get some stuff in the jumbotron. Let's see. So. Let me find my screenshots here, because I know it's one of the best things that everyone likes to bring up. Well, how does it possibly work on flat Earth? And it's like, well, it's super easy, actually, right? If you look at the model over here and we put, say, an observer, let's put a Western Australia, he would see, let's say that we have a star, a cluster of stars that represent, let's say it's this one. It doesn't matter because they aren't real and they're all the same. Let's say it's this one. This person would see it right over here. Let's say it's this little star right here, right on his southern horizon looking south. That's exactly where it would appear. And let's keep track of it as we move. Again, we're not going to move time. We're just going to move our observer. So we're going to go this way. We're going to go back to Africa right over here. We're going to look at the same star. It's going to be right above him, right over here, this green dot. There it is. Here it is. So it hasn't moved. It's in the sky. And we're going to move our observer back to the South America, the last observation point where it is just barely nighttime, and he will see it right over here, looking south. Right over here is where he sees it, right over there. So they're all looking south-southwest. They're all seeing the same Southern Cross, seeing it at different elevations, at different peaks, but at the same time, technically, from flat Earth. So that's super cool. Do we have questions? We've been doing this for quite a while.
Oh, yeah, looks like we're going on about 2 hours here now. Go ahead, GT. I saw you open your mic. You are always free to speak.
Yeah, I grabbed my computer because I was having some issues, some technical issues. Can you hear me?
Yeah.
Okay. Yeah, I had a couple questions. I had to get the kids down. You know, that's half the reason why I'm even doing what I'm doing is because I have 3 small children, and I just want to tell them the truth of where they live and try to figure this whole thing out. Because if flat Earth was just totally stupid, it would have been canned a long time ago. And so it's been fun to investigate. If I jumped all the way back to the gentleman that brought up the drone, and he was saying like the sun will appear to set. And, you know, I really appreciate everybody that's been cordial with their questions. And he's like, hey, but if I take my drone up, I can see it for like exactly 2 more minutes. My hypothesis is that if you take a drone and you go up, you know, 200 or 500 or 1,000, you know, feet, that would be a bigger Earth. Like the Earth would have a bigger radius if you're viewing from there. And it seems that the grid of vision would be a little bit extended. So you're being able to see that sun slipping away on a larger grid of vision because the way the Earth was calculated was ground level. Am I right in thinking that?
Yeah.
I mean, that's the only way that it makes sense to me is like if we see the sun set and the sun is optically doing that, if you take a drone up, then of course, you know, you may be able to see it again. But I wanted to circle back to that just because that's what was bouncing around in my head. But concerning the model specifically, I understand that like Bislin did it as like a joke or was trying to like rub it in our faces, but what data did he use? Because quite a bit of it is exactly how we see, you know, the apparent sun and moon go by or the stars. So a lot of it's right. And the wrong part was when the bendy light ray lines were bent all the way up to a sun. That ultimately he was saying like, well, if you had a sun over a flat Earth, everybody could see it at the right time or at the same time. Is that correct?
Yeah, and the definite flat earther, anti-flat earther misunderstanding of the sun, but attributing all them heliocentric attributes to it, and then seeing like, oh, I can't see how it works. Like,
right.
Yeah, I got it.
Okay. Yeah. I mean, this whole thing is amazing. I wanted to ask B1B or whatever, like the attitude that I think you need to bring to this is if you can imagine, because I think it is a stationary topographical plane, first you have to put yourself on an extended plane that's not moving. Like if you're going to enter this space to even discuss, you know, where we're living, then you have to say, how could it be possible to see a sun appearing to rise, hitting a zenith, and going down and setting if we're on a plane? The answer would be, well, because it's optical. That's how it looks to us. And I really appreciate all the hard work you guys have been pouring into reading papers. You know, people have been debating and talking about, you know, geocentrism. They've been talking about the flat earth since the early 1900s, and it's been a waging war with books and studies. And I just like that you guys are bringing not just what you think, but you're looking at papers and analyzing what people before you thought. And it's exciting, man, because like if we're wrong, like if flat earthers are just dumb, that's going to be totally fine. Just show us the proof of the globe, show us the proof of motion, and I'm going to adopt that back because I want to show my kids what's real and what's true. And to me, obviously, the heliocentric model is based on philosophy and can't be proven. So that's why I think all these people are looking into this. So thank you.
Awesome as always, JT. Also, thanks for the coffee cup caustic thing. I just noticed that you sent me, other man.
Yeah, man. I think that's all I got. Pass the mic.
Thanks, Mayor.
I gotta give him this title.
Call him Mayor or May for short. Like, what up,
I
May?
like Mayor. It says professional. Like, yes, Mayor. I will, Mayor.
No, you guys are funny. Oh, I got one more thing. Last thing. The gentleman that was asking about like the moon and how it was like relating to the background stars from Homeboy in the north and somebody in the south. Well, one mistake would be if you can't stop seeing people like on a globe, that's a problem. But if you can envision them on a plain Earth, the first question I would ask people, everybody listening, is, hey, does the sun and the moon look different than the stars and the wandering stars? And if you're like, well, yeah, like the sun's super bright, it feels hot, it's like it's intense, and the moon is like a different color light, but both those luminaries are big, like they're different. And so if somebody's in the north of the equator and somebody's in the south of the equator and they're close enough to see the moon, it's just like that, like a 6 on the ceiling, where the person taking the picture in the north is going to have an upside down picture of the person taking it in the south. And that's kind of a cool optical thing. But if the sun and the moon do look slightly different to the background stars, I would just say that the background stars may be in a different location outside the azimuthal grid of vision. And the way like the bottom line here, people, is the way all the heavens, all the stars, all the luminaries, the way they present to us is what they've been doing for thousands of years. And I think it's awesome. I do think we live on a plane, a stationary topographical plane Earth. And exactly how it works and what the model exactly is going to be difficult to get, because we're just starting like 10 years into this thing, like us, like the people on the panel. I don't think anybody's longer than 15 years looking into it, because we just awoken from the deception. But what we're fighting against is billions of dollars and almost 500 years of peer-reviewed studies and papers and analyzation of the sky. But every time somebody's looked at the sky, they're using optics, they're using telescopes, they're using their eyes, and they're getting data of what Shane is presenting. He's not just some dumb flat earther that's just making something up. Like, the night sky is the puzzle piece that we do have. And the real question is what's under our feet, and we're all digging at that. So anyway, I'm not going to ramble anymore, but I love y'all. Thanks for being truthers.
Nice, JT.
Thanks, May.
Dude, yeah, I forgot his title. Man, I got to remember. Dude, you remember that when we were going through the Royal Society and we were talking about the collimation mode? Or what was it called? The collimated, when the old school G's had to denote the edges of their azimuthal grid of vision.
Oh, are you talking about when they founded the azimuthal grid by looking at one horizon and then flipping the telescope 180 degrees and doing it opposite?
Exactly that.
Yeah, I remember
it's
that.
Almost like before, because someone said about the moon and the parallax, but it's important to note, before they invented longitude and the need for it subsequently, they used something called like the lunar transit method to get around, to celestially navigate. And what that was they'd mark the moon as it passed by certain stars. Literally, they could see which stars it occulted and then know how long it had passed since between that and Jupiter's moon's method and just the dead reckoning, they managed to get along without any longitude just nicely. But the point is, they looked at something called the clock stars, which are like these really bright stars that the moon would pass by, and then it would transit those, was how they would tell time and be able to navigate. So the parallax behind the moon and the net of stars is something that I don't understand this question, because it's been known and used and exploited and navigated by for at least a couple hundred years. So.
Wow, I did not know that about the
yeah, but if you assume
transit.
his exact medium, his exact refractive index, his exact distance, and his exact sizes, then it's all real. It all matches.
You could tell because he was like, but it matches heliocentrism. It's like, you mean observations?
Well, not to. That's how they got us, though, right? they get us with these fantastical distances and attribute meaning to them, and we forget the significance of the practical application of what it is, right? We completely overlook the fact that none of that matters, and it's all about a local personalized azimuthal grid that two observers can use to navigate on a coordinate system that was given to us by the king in 1777. Shout out to the king. Hooked us up with that hooked us up with that universal lat long, dude. I mean, I'm mad, but also
won't need any other coordinate systems.
yeah.
Also, you can't use any others, but you're all set. You can have this one.
I'm mad, but I can't be too mad, right? They did do a very impressive feat. When you go over the history of how they made the lat long system, it's fascinating. Shane did a whole thing on it. Check it out on Ether Cosmology. It's called Finding Latitude, or Where Did I Put My Longitude? I forget what it's titled, but go to YouTube, Ether Cosmology, and type longitude in the search feature, and you'll find the history of it. It's really fascinating.
It sure is.
Yeah, Alan, it was so good. I re-uploaded it to my channel. I don't have very many videos, but I'm going to be putting up more and more of people having great conversations. I'm going to be clipping stuff, and soon, in the near future, I'm going to start doing interviews with people, just like talking about, what do they think and their truth or journey. And I mean, really, this whole movement is about connecting back to people connecting, because the world, it seems like, has been pushing division. Like, let's divide over everything. Let's be angry at each other. Anyway, so yeah, you can go to youtube.com/@runbostonbear, and you can find that longitude latitude video, like, not very far down.
Dude,
I do recommend his cut, because it's a nice, well edited audio track.
It's epic.
Yeah. If you go to Run Boston Bears YouTube channel and type "Dude, where's my longitude?" it'll come up, and you can watch the video. Hey, I stole that joke from Big Pine Sailing. Shout out to him in the chat. That was hilarious, dude. I've been laughing ever since I read that.
Oh, I see that when I kicked out my OBS, my Twitter stream stopped. I was like, it reset like 3 times. That's going to be annoying, dude, when I do Flat Earth Fridays. Got to get that 9-hour stream to compete with Alan.
Yeah, dude, I've been enjoying Flat Earth Fridays, and then Stationary Saturdays. Sacred and Proud Flurf have been just opening it up to anybody, and man, they've done 12, even 17-hour streams. So this is definitely a topic that I find very fun to talk about. As long as people can stay chill, like, there's no reason to get angry. We're just talking about what could be. I guess that's my thing, is let's just talk about it, not use ad homs and get angry about it.
Absolutely, bro. Well said.
Cool.
So if anyone else has any questions, comments, or anything for the for the model or anything, if not, we're probably going to wrap up. Then we'll go through the TL later, post links and tag everything, etc.
Yep.
More so of a question, not more so a comment than a question. First of all, I'll shout out to you guys for rolling with the punches, man. How many times can you say something over and over and over, and they're like, "You didn't answer my question"? I'm like, "All right." He kind of did like 5 times, but all right. Anyway, I think that people struggle because of what you said. They can't get that other model out of their head as they're listening to you talk about optics and how our grid of vision works. My oversimplified analogy is that if you see a rainbow, probably maybe way too oversimplified, but it kind of works the same way.
No, this is a great analogy, bro. You said it the other day, and I really like it. Keep going.
Yeah, it's perfect. Yeah.
Cool. Let's for the audience, what I said was, if we all see a rainbow, we can generally see where the rainbow is in our grid of vision, and we can kind of model that. But we couldn't triangulate exactly where that is. Kind of like the impression of the globe of a physical object of a celestial body. If that is presupposed that it's a celestial object, we can understand that. But all we know is that rainbow is apparent. What we know, a rainbow is only apparent. We know it's not a physical object because we know what a rainbow is. We don't assert what the sun is. That's one thing that these guys are great at. They only talk about what they can prove, and they know for a fact that the celestial body is apparent. So you can model out a grid of vision to a rainbow, but you can triangulate. That triangulation, you got to get out of your head. That is the indoctrination. They will say over and over and over, but we can triangulate from these 3 locations. No, you can't.
Well,
that
well,
has
well, hold
been
on. If you impose
the go.
conditions on the rainbow, you definitely can, right? And that's what and that's what they did, right? They were like, okay, well, if we say the rainbow is this far away relative to your position, now we can set up our 2-party position. That's what they did. It was all about in 1777. The whole thing was getting people to use a rainbow to navigate, right? So we get 2 people to do it. If we can get 2 people to do it, then we're golden, and that's what the whole thing was about in 1777.
Exactly.
So yeah,
Exactly. Bro.
Yeah,
Shout out to you guys, man.
I love
That's
that
all I have to say.
analogy because it's like, oh, if you think like if you're gonna assert the people that are asserting that we should be able to assert or we should be able to triangulate positions of these apparent things, like literally they're the same. Like, okay, well then go get me the pot of gold from the end of the rainbow. Like that's like literally the same level of logic. Kind of hilarious.
Did Xavier finish?
He
No, that's all I had to say. I landed it right there. You guys are awesome. Keep it up, though.
Thanks, bro. We love listening to what you have to say too. You got some gravy all the time. It's good to follow. It's good to have a crew of competent people who are all like proficient at things. You know what I mean? Love it.
Yeah. So, any other questions, thoughts before we wrap up the space here? All right, then.
All right. If there's no further questions before you do our outro, Toby, I'm going to be playing a 10-minute video at the end that somebody requested I play. I'm not really sure what it is or what it's about, but if you're interested in that mystery and solving that, stick around. I'll be playing it on Twitter, whatever. You can watch it on there. You can watch it on YouTube if you're on YouTube. But after he wraps up the outro, I'm going to play that video.
Yeah, you can go watch that on his stream he's referring to, not in the Twitter space itself. I'll go ahead and close that out once I do the outro here. But yeah, so everyone, thank you so much for being here. I'm not so sure how this recorded space is going to sound because I was having audio issues hearing people from the actual space, but you can check it out over on Shane's platforms on BitChute and Odyssey and Rumble. You can also check out Alan's platforms on Rumble and YouTube. And yeah, check out Space Audits, and then I'll be mirroring the Space Audits stream over to the Ether Cosmology channels as well. But yeah, so thank you so much for tuning in. If you have questions, just ping us. We'll do our best to get to them, especially if you're respectful. Yeah, tomorrow night we're going to be doing an Ether Roundtable. It's going to be hosted by mostly by Alan. I believe Man of Stone is going to pop in as well. We're going to have some discussion about kinematics and dynamics and the difference between the two and the meaning between the two. And then we're also going to do a little bit of a dive into some of Man of Stone's videos and discuss those and do a little bit of a discussion with Man of Stone about those videos. And then also, so that'll be tomorrow at 7 p.m. Eastern time. And then on Thursday nights, we do reading. We do live reading and research. That usually starts at around 9 or 9:30 p.m. Eastern time. So join us for that on Thursday. And then also, of course, on Friday, there is Flat Earth Fridays. So I'm sure many of us will see many of you there. And yeah.
One final note. Yes, I don't think I said it the whole time, but this model isn't for me to use. It's for everyone in the community to use, to pick it up in a debate, to show a globy, to do whatever. It's literally to explain the unexplainable. So the things that Flat Earth couldn't explain, the sun, the moon, eclipses, sunrise, sunset, moonrise, moonset, all the things that were tough to explain. That's what it's for anyone to grab. So thanks everyone for coming and for asking pretty good questions.
Take care, y'all. Thanks again for being here.
Yeah, you can stick around right here. I'm about to play it here in a second. Yo, what's up, Toby? I'm still live right now. I'm about to stream this video. Do you want to watch it?
Yeah, heck yeah.
All right, cool. Waiting for Shane real quick to see if he'll join us. All right, I'm gonna go ahead and assume he immediately went to go take out his dog or something. So we're just gonna play this out. He can tag in if it comes back. All right, distribution of the stars in the upper Fermi.
Well, that went well.
Oh, hey, you're back. I'm about to play this video out that somebody wanted me to play regarding the stars and the firmament and stuff. If you want to check it out, I'm playing it now. If you want to join the thing and watch it.
Yeah, we are live on Space Audit still.
Yep. Let me know when you're ready.
Oh, I'm good.
Okay, playing it in now. Also, it was distribution of the stars in the firmament. I put this on 2x play speed. Nice, bro. Thank you for the video. Thoughts, anyone?
That stuff about the star distribution is really interesting. I'm gonna have to look into that some more.
I'm gonna need that link. Yeah, I'm gonna check that out.
Oh, absolutely. Here's the link in the chat. Or, yeah, chat. There we go. And then that link one more time for anyone who wants it on the YouTubes. All right.
Nice.
All right, cool. So Toby already outroed us out, and we were going to exit on that video. So thanks, everyone, for tuning in. And we'll be live tomorrow at 7 to discuss kinematics and dynamics.